Testing 1 2 3. Testing 1 2 3. Testing. Yo, start with the wait, guys. Yo, what's up? Welcome back to Vencabot. Into the Python action. My name is David. We're talking about Python programming, tutorial type stuff. You guys know the deal here by now. It's episode 5 of our 6-episode series. Usually 6 episodes for these seasons. In the past, we've done other seasons of other games. Right now, we're doing like a virtual pet. And we started off with the very basics of, what is a function? What is a program? What is, what counts as data? What's an operation? What's a variable? That was day 1. As we've gone on, we've introduced, introduced some new concepts, some more advanced type stuff. Hopefully, as we're going, it's kind of teaching you to think like a programmer and understand why we're using the tools we're using and how. And last time we talked about mutability, right? So in the past, we talked about like function definitions, returning values and arguments. We've been using mutability as a way to kind of minimize the arguments we have to use and the return values and make things a little bit more streamlined. We created this big game state dictionary. Right. Before we had a bunch of variables here that were sort of just like named data, named pieces of data. But now we only have one named piece of data, the game state. Everything else is a key inside the dictionary. Right. We talked about lists last time, about indexes, and how that kind of compares to tuples. Tuples are more like multiple pieces of data packaged together that all serve one purpose, and a list is more like a sequence of the same kind of data. And we talked about how that compares to dictionaries, which are kind of like, they're not really in order like a list is. Instead, you have a piece of data that sort of has a key, has a name attached to it. So you see why these little lists here. Lasagna and pie have the key favorite foods. Tofu, Brussels sprouts, black-eyed peas, and okra, that's another list, have the key pets hated foods. We have integers here, 50 and 100, which are the pets happiness and hunger in the game state. And before we had these being in their own variables like this, right? A little variable there. Pets happiness equals 50. Very clear back in the day for us. But to make it more streamlined, to have it all be in one big package together, we put it inside of a dictionary for our purposes here. The game state's a dictionary. We put it at the key. Pets happiness. It's a string, right? In a dictionary, you have one kind of data, which can be a string or an integer, whatever you want, attached to another kind of data. In this case, an integer. We have a string paired to an integer here. We have a string paired to a list here. The list itself has a bunch of strings inside of it. Globals are a pain to refactor. Better make it functional first time by passing, then refactor later. Class starters are glorified dicks. Changed my mind. Well, they kind of are. They can be looked at that way. But it's, syntactically, it's quite a bit nicer to have it being an object. It was a bootcamp testing 1 2 3 4 5 6. Before this stream started, me and my friend Userman were talking about functional programming and its merits. How functional programmers try to avoid mutability as much as they can. In our case, we're trying to embrace mutability as new programmers here. It's very important for beginners, I think, to kind of see how this works and what's really strong about it, and the difference between immutable and immutable data. So we have our program here, and we've broken it up into some very neat little functions. Right? And I say very neat. Part of why it's so neat is because we have this one argument now and no return values. Right? So we have this feed pet argument. Right? We have that function. We have the play with pet function. We have a put pet to bed function. We have like a virtual pet game here, by the way, guys. Clean up poop function. A cheating function. So I type in dagger. So we've kind of been trying to break up our program into very easy to read little functions so you know what each one does independently. I think it's pretty clear what they do and how they work, right? We have a little feeding code there. We've got playing with the pet code. We've got some putting the pet to bed code, clean up poop code, and a cheat code, which is great. We define our functions first, and then we define our game state after that. And then here we have this little loop, which is our main game here, right? This is our main little game. Actually, the main game happens right here. Right, that's where the main game happens. Once we take our turn, so to speak, it's not like a turn-based game. We take our turn doing what we want to do with the pet, have it be fed or have it played with us or whatever, put it to bed. Once we do all that stuff, then we run this code down here at the end of every turn to figure out how the pet's happiness has changed based on what we just did. Right. This stuff here. Right, so at the end of the turn, if the pet's hungry, it becomes less happy. If it's poop on the floor, it becomes less happy. And if the pet is too unhappy, it's game over. The pet bites us and it ends. So it's kind of a drag there. But yeah, overall, pretty simple. We have not that many lines of code. It's a little more than 100 lines, about 150 lines. But we can actually make that a little bit cleaner as time goes on. So before we get started here with our new things today, which I want to talk about objects and classes for the first time ever on this season. Before we do that, let's have a look at the way our code works in general. Right? So we talked a million times about how when you have a code block, that's a piece of code that's indented, like this is all indented, right? it will not run necessarily. Right? Any code on the far left of the screen will always run. This code right here is going to run always. Right? However, these functions up here, they will not run when we scroll through top to bottom. Right? Only the first line is going to run, which defines the function. It's being defined here so we can use it later, but it only runs when we call it. This code right here is not going to run for us right away. We have to call that function for it to run. So basically, programs do read top to bottom, but indentation is important. Right? It reads top to bottom, but the stuff that's indented will not run necessarily. So the first thing that happens in our program is on line 1. That's we define this function here, feed pet. Then all this code gets skipped, because functions will not run unless you actually call them. All this code gets skipped. So where's our next line that actually runs in our program? This line right here. We define another function, play with pet. Then this code here gets skipped, because we're going to come back to this later, right? We can call the function and run it, but right now it doesn't run. Okay. Next thing that happens, we define put pet to bed as a function. We define clean up poop as a function. We define cheat as a function. So we define some functions to make the game work. Then we start defining the actual game state. So here we start defining like our actual variables, so the actual data in our game. So we have, pet's favorite foods or hated foods. That's for feeding the pet. They have a happiness level, a hunger level, whether or not the poop is on the floor right now. They have the pet's name, which we ask for using the input function. Right, we ask for the name right there for your pet. And then we have this taking care of pet equals true. So if you put the bed to bed, or if it bites you, you stop taking care of it, and then the game ends. Right? And here we have our commands. Right? So our commands are what you type in. And it's a dictionary, right, where it maps a key, a string, the user's going to type in, to a function. Right? So if I type in feed, then you run feed pet. If I type in play, then you run play with pet. If you type in quit, then you run put pet to bed. Right? So these are the commands I type in that are paired to the functions you run if I type in that command. Right? Print a blank line. We get to our main game here. It says while we're taking care of the pet. Right, as long as this dictionary value, taking care of pet, is true, then keep on running this indented code block. Right, so it starts off as being true right here, right? We define that as being true right off the bat, so it's going to run at least once, this while loop. When it hits the bottom, it's going to see if it wants to run again, if that's still true or not. So while we're taking care of the pet, this all runs. Right here, all this code block right here that's highlighted. It's going to run for us. First thing it does is it asks what you want to do. Right? And it can ask you two different ways. If there's poop on the floor, it asks if you want to clean up the poop. Otherwise, it doesn't. So we have two different kind of options here for asking the player if they want to play with the pet. Right? I think maybe today is a good time for us to talk about F strings. Right? So previously on previous episodes, we've been trying to keep it very simple here with these strings, where we can add strings together. Right? We have here, do you want to feed or play with plus the game state pet's name, that's a string, plus question mark, right? So do you want to play with, Vencabot? If I was, the pet's name was Vencabot. Right? We're adding strings together. But in Python, we have what's called an F string. This is a new feature in Python as of 3.4, I think, which came out, a couple years ago. And that means that we can actually make these a lot easier to write and read by using this F. Put an F there right before the string. That means that any text in this string, you can start putting variables directly into it using curly brackets. So I can do something like this. Watch, I can say here, do you want to play with, then we'll do F, F string, then do curly brackets, like that. You can't have a quotation mark inside your string, because that'll actually end the string. I'm going to show you a bug with that real quick. Right, so what I can do here is I can change these this string right here ends right here. Right, because we have strings end with quotation marks. So even though this pet's name here is actually supposed to be a string inside of a string as a key, actually ends our string on accident. It's a syntax error. But what we can do is actually surround them with single quotes instead. Right, there you go. So single quotes and double quotes both work for ending strings. Right, so now we have this whole string, the whole F string right here. And then we also have this little string inside of that we're using as the key. Right, so with F strings, you can actually avoid having to... this might be too long. Yeah, it is. We can avoid having to use a whole lot of concatenation. There we go. Also, you guys should know that inside of a brackets, parentheses like this, string literals like this will automatically be concatenated. There's no plus sign needed right here. They're the bomb. Okay, they're the bomb. Although I feel like maybe as a tutorial is not the best time to teach about them because these they look kind of ugly with these dictionary calls. Anyway, so inside of a parentheses, you can add strings using plus, or you can just skip the plus and they get added together automatically. Apparently, idle does not highlight f-string fragments. What's an f-string fragment? What do you mean? Everything seems highlighted here so far. Oh. If I put it right here. What if I do it up here? I don't know if it highlights anything, really. It doesn't highlight the brackets either. You know what I mean? Yeah, it seems to... Oh, there we go. Yeah, it seems to be pretty... it doesn't seem to like to highlight, like, starting and ending brackets for anything, it seems like. Okay, so that's cool. I'm going to do some more F strings here. Make life a little bit easier. Lots of plus, adding in certain strings together here. Let's make this an F string. Okay, once again, we actually got to turn this into single brackets, single quotes, to not end our string early. Okay. That'll do. There we go. Awesome. Sweet. Amazing. By the way, I looked into the byte code for plus versus thing, new line, other thing, and it seems to be more efficient than the byte code for string plus string. Okay. Interesting you mentioned that, userman, although I think in Python it's typically frowned upon to look too much into optimization. Really more about, usually the most Pythonic answer is to do whatever looks the cleanest. And it's going to be a matter of preference, perhaps. But interesting you mentioned that, though. It's good to know, at the very least. Have a good time, okay, right? Be careful out there. Don't you do a car crash and die or anything. Yeah, have fun at your event, Black. That's going to play some Magic. If you ever get curious about Magic again, feel free to shoot me a message here. They're here on Facebook. I will, Black. I will. You're going to be the guy I ask, guaranteed. If and when that day comes. I wouldn't trust anybody else except for you. Okay, so we ask them what to, if they want to feed the pet or not. That's fine. And then we try and call that command. So basically, we go through our commands dictionary. Up here, we define that, right? We have a dictionary here of commands. Feed, play, quit, clean, and dagger is our cheat code. Right? These commands up here. And we try and say here, get the function, the callable, from that dictionary at the key, whatever the user typed in. Right? Whether they typed in as pet activity, then use that as the key and get it out there. So I typed in, the word play, then we use a play string as our key and get play with pet as our command callable. Command callable equals whatever we get out of the dictionary by giving it what the user typed in. However, that could be a problem, right? If the user typed in, let's say, the word, ding dong, which they might if they're me, then we're going to have a key error. It's going to crash our program because our dictionary here has no key, ding dong. It has 5 keys: feed, play, quit, clean, and dagger. Right? So if you give it the wrong kind of key, it's going to crash our program unless we put this inside of a try block. I didn't actually go over this last time that much. Basically, a try block says, try this code, and if it errors out, don't crash the program. Instead, handle the error gracefully. So in our case, we're saying here, if we get a key error, then ask the user to please type in either feed, play, quit, or clean. Right, and then continue. Right, so in other words, it says here, if they typed in something that we don't know how to handle, then just remind them what we know how to handle, and then carry on. Have fun, Black. Plus makes a binary add bytecode, whereas a string, new line string, uses a build string bytecode. So I don't know what's better, but it's interesting to know. Yeah, it's kind of interesting to know that there is a difference. It's not even commonly known, not even widely known, that in Python you can break lines and have strings automatically concatenate. Okay. So after that, after our game is, after we've fed the pet or played with it, we run this code down here to see if they're happy or not. This code is a little bit long. I think what I would rather do is have this being a function, perhaps. So what would be a good function name for this? We have to kind of evaluate pet's new happiness, right? Or we'll say like end turn maybe. We'll call this like end turn. What's up, TOW? TOW23? You missed class. Sorry to hear that, bro. I'm not sure we've met. If we have, it's maybe a different name, huh? Welcome aboard, Home Slice. Fuck class, dude. I don't need no education. I don't need no thoughts controlled. Let's make a new function here. Def end turn. Give it the game state to work with. Paste our code. Okay. So that should be fine already. Good. Now we can go down here and delete this code from down here. And simply make it into a function call. Right, end turn. Okay, so we prompt the user for, for their input. That's good. I might hide that in a function too, to be honest. Let's go do that. Grab it. Grab it. I want to go up here to the very tippity top. Tippity top. I think I'm going to make this into a more proper function. Say def, we're going to say here, input pet activity, give the game state, and we're going to say here, is there anything else need a command map? Right. That's fine. Okay, so we're going to say here, I need this command, no, it doesn't need a command map. Not yet. Okay, that's fine. We're going to return pet activity here. There we go. Okay. Sweet. Give this code. We're going to say instead here, pet activity equals input pet activity game state. Right, there we go. I'm sure it really needs a game state. What does it use it for? Just to see if there's poop on the floor, right? Seems kind of wasteful to give it that. Let's just have it always ask if you want to clean. Do you want to feed play? We'll say, do you want to feed, play, or clean? There we go. And, oh, we have to have the pet's name too. Alright, fine. Give her the game state then. Okay. Wow. Really terrible undo. Oh, man. Here we go. Bro, would you recommend to learn Python? I'm trying to understand the question, Toe. I would recommend it for sure. I would highly recommend it. It's a very powerful, very easy to learn language for a beginner. If you're already familiar with, let's say, C++ or some other C#, whatever, maybe you don't have to learn it. But it's a really fun script language, so it's not a whole lot of compiling going on. I would say it's a pleasure to use. Alright, give it the game state, that's fine. Whatever. Print a blank line. Here's our little command for calling the function. Okay. Sweet. Might put that in a function too then, huh? It doesn't even need the game state. It does need the game state for that. Okay. All right. So we'll say here, like run command. I'm gonna copy this code down here. We don't need no education. We don't need no thoughts controlled. So we're going to say here, define a new function, right? How about like run player command, game state, player command. We'll say game state command map and player command. Right. That'll do. All right, so we're going to try the command call from the commands list. We're going to call this command map. Player command right here. Okay. There's a good chance for us to experiment with the list a little bit, right? And show the player the available commands. We kind of can. It'll show us the cheat code, though. That's fine. Okay, command callable. Game state. All right. That'll do. Let's go down here and change our code. I'm trying to move the code around and make it as easy to read as possible. Right? Make it kind of break it up into little pieces. Easier to digest. Right? Okay, so let's move on down here. Okay. So now we can say run player command, game state, commands, and pet activity. There we go. Okay, so now we have a much simpler while loop down here. We can see what's happening, right? Get the player's input for the pet activity, and then run the player's command, and then end the turn. Okay, quite simple now. And then we talked before about how if you break up your code into smaller pieces, like functions or classes we're going to learn about today, it makes it easier for the programmer looking at your code to manage their investment. Which resource would you recommend to learn at Python? Well, there's all kinds of cool resources. I recommend the official tutorial and documentation at docs.python.org. Also on YouTube, we have all kinds of other tutorials over there, man. You can go watch Intro to Python Season 1, 2, and 3 over there. They're pretty useful, I think. You can probably become a Python pro in about 8 hours of lectures. I'm very proud of those tutorials. Aside from that, man, again, I learned mostly from the official Python tutorial. What's up, Vucat? At docs.python.org. If you go to YouTube and look up Vencabot Python, you'll find our playlist for Intro to Python. I think it's called Intro to Python. It has 3 seasons there. We learned how to make a Pokemon game, Season 1. We learned about how to make a text-based adventure game, like a puzzle game, Season 2. And then Season 3 was like an RPG. That's my favorite. It's kind of like Dragon Warrior. We're on Season 4 now, Episode 5. Yeah, I don't know about Udemy. I haven't ever used Udemy. You also find his best-selling Pokemon clone there. Yeah, exactly. Best-selling Pokemon clone. Data Camp as well. Huh? Okay. All right, so now our code's more broken up, although I do see there's still the feeding code is still very long. We could actually break that up even more if we wanted to. Right, it's a little bit long. It's still quite simple, but we have a lot of long little... logic trees. Now we can break this up into a dictionary. Right? We see how it's kind of like we have a value, and then that's paired to a string, essentially, right? A value, we have that paired to a string. There's not really much for a dictionary, though. That's fine. What else we got here? We have this another logic tree here. Feed the pet one of these things that gives you back a different message or a different value back. That's all good. Okay. Let's see here. I think life's good right now, guys. We've kind of cleaned up our code a little bit before we get started with our new stuff today. So let's do a very short review, guys. I'm going to make a little lecture here in our notes document and then get started today with object-oriented programming. All right, let's see here. So in the past, one thing we've focused on a lot in our code is readability. I think that programmers at all skill levels underestimate how important it is for your code to be readable. Right? If your code is difficult to understand at a glance, it's going to be difficult for you to maintain enthusiasm about continuing to work on it. as it gets longer and more complex. Back when I was new, I would sort of lose touch with my own projects after they reached a certain level of complexity. Because you want to continue adding features, but it becomes more and more difficult to know, how and where to add them as your program gets longer and longer. Right. So a big part of programming is not just figuring out how to solve the problems you need to solve in order to make it work, the way you want it to work. You also have to figure out how to lay it out, right? It's sort of like engineering, right, or design. You have this big text document, or in the future, many separate text documents. And it becomes your job to decide how it's laid out. And as you do that, I stress that you consider readability, making it clear how it works, and breaking it into small but sensible pieces, so that when you want to work on just one part of your program, you can do so easily without having to worry too much about the other parts. Right? So we talked before about, for instance, our feed pet command, right? You can see here all the code needed for feeding the pet. It's all very neatly right here. Right? That's real nice, I think. That way, if you want to work on feeding the pet, it's right there. If you want to work on how you play with the pet, that's right here in the play with pet. Right? Now, before when we started, it was all in one big column down here at the bottom. Right? All the code for feeding and playing with and quitting was all in one big block. So I think we've made some progress by breaking up a little bit, and we're going to learn more today about objects and classes and how it's going to help us make our code more organized and more sensible. How did you learn Vim? Just over time. If project, if is getting bigger, if bigger, if and, if you, if cannot, if refactor it, restart project. Yeah, it's a kind of a drag. I think it sounds like a user man's been through my same situation, right? Where you have a project you're working on for a very long time, you make a lot of progress on it, but it becomes so massive and so unwieldy that it's kind of hard to make more progress. So if you work early on deciding how to make your program more readable, it makes it a lot more fun to work on in the future. So in our case now, our main code is just this. Our main code is very short and very simple. Right? It's kind of nice. And it's just a few lines. But these few lines, they point toward more complexity, right? We hid our complexity behind these function calls, and from reading the name of the function call, you know what's happening, right? We have to get the input pet activity, we get what the player wants, right? And then we run the command they want to run, then we end the turn. If you want to see how these work, at a more granular level, you can scroll up and find them and read how they work. That's kind of the idea here. So, let's do some more review here real quick. Last time, we touched on the subject of mutability, right? We discussed how most, I'll say many, data types cannot be altered once they're created. But others, such as lists and dictionaries, can have their values updated over time. We discussed how this can be empowering because it allows us to share a single piece of data across multiple functions such that the function itself can alter the data, and other functions and scopes can have access to those changes. Right? We talked about that last time, about how we have these functions now, that they take this game state argument, right? So we learned that functions, they can only have access to things you give them as an argument. Right? If it's not inside these parentheses, they can't know what it is. They have no idea what the hell it is. So they know what the game state is. That's all they know. Right? But what's cool about the game state is that it's a dictionary. So we can actually change things in it, like the pet's happiness right here. And although that change is being made inside the function, other functions that use the game state can also see that change. Whereas if I give it, let's say, an integer or a string or whatever we used to give it, it cannot do that. It has to return values out, which is not necessarily a bad thing, but in our case, it's not working out for us. Right? So previously we learned that what happens in a function stays in a function. Right? You give it some immutable arguments, and it uses those arguments. They're only for reading. They can't write to those arguments, but they read them, and they make some changes to some things, and then they return those things back out that were changed. Think of a function like a worker that does a job. Right? You give it some tools, it does its job, it gives you back something in return. It's kind of the idea usually for a function, right? However, if you give it a mutable argument, like a game state, a dictionary, right? That's mutable. It can be changed. The function can change that mutable object, and that could be its job. Let's go talk about that down here. Right. So, when we first introduced functions, we looked at them as doing a very clear job, taking input, arguments, and producing output, right? Return values, right? Because of what's called scope in programming, functions don't have access to the same variables that you've created outside the function, right? They do sometimes, but that's outside of what we're talking about as beginners. Right? As a beginner, look at it like this, right? Your function only knows the data that it defines inside of itself. If you define data outside of the function does not know what that data is, right? That's not always true, but as you become stronger, you can worry about that later, in your programming career. For our purposes, we're going to say that's pretty much a rule, right? So if you want for a function to know anything about the world outside of it, you have to supply that data as arguments, right? That's effectively, for now, the only way to get data into a function. For the same reason, scope, or the scope of the function, if you define data inside of a function, that data does not exist outside of the function, right? So you can think of a function as its own little program, right? The only data it has access to is the data that it defines or takes as an input, and the data that you define inside of it, can't be used outside of it unless it returns that data to the other scope. Thank you for the follow, Poop2343. Poop, huh? What's up, Zanzu? That says, well then, function scoping is violating the function's rights. Free functions. Yo, fuck functions, dude. They gotta learn their place. So we have to return data, to the scope that called the function. Right? So, what happens in a function stays in a function. Right? That's what we learned early on. But it's not necessarily true. That's only true when you supply immutable data as the function's arguments. Right? If a function takes a piece of mutable data as an argument, data that can be mutated, then a part of what that function is likely to do as its job will be to mutate that data. And what's interesting about that is that even in other scopes, such as outside of the function, that data that change, that mutation, will be respected, right? It's something that actually happened. So, you know, typically, so a function's going to do, rephrase that. A function's job is to do two things, right? It can take input and return output, and it can take a mutable input and mutate that input, right? So, you know, by its very nature, a function's purpose is to do a job. So it's always going to be doing one of those two things. Right. Or both. Although that might not be recommended. Because it can get confusing. Right. So in our old code, we used to have functions that took an input and they give us back a return output. But now our functions simply take a mutable input and they mutate that input. That's their job. Right? So let's see how that works. So we have this mutable data. Right? The mutable data is this game state. And it's a dictionary that has all the values we need that will be changing throughout the game. Or that the game might need to know. Right? There's all these little keys inside of it that point toward these little bits of data that are going to be changing throughout the game, such as the pet's happiness level, the hunger level. It's going to be going up and down. Poop on the floor, you know, they're going to poop on the floor. It's going to turn to true. Clean up the poop. It's going to become false again. All right. So we have these functions now, these commands like feed the pet and clean up poop, put pet to bed, and play with pet. Their whole job is to take the game state, this immutable data, and then change the game state. Right? Their job is now to take a mutable argument and change that data that it got. That's its job now. Right, whereas the job before was to take some immutable arguments and then work with them and then return some new data back. Right, so kind of change the way our functions work in our game. It wasn't a nap. What do you mean, Zanzu? How'd you fail the nap? Nap is not that hard. What'd you do wrong? Okay, nice. Nice. So, today we're talking about objects and classes. Let's go talk about that real quick right here. Well, you slept. Oh, I see what you mean. Well, there's nothing wrong with that. Sleep is good. That's like a nap plus plus. Because nap means rest. You know, sleep is just a super ripped nap, dude. It's like a really hench nap. Don't at me. Sleep's always better than a nap. I'm sorry about all the ums. We've learned a lot about different kinds of data over the past few streams. Most of it has been immutable, right? Such as, you know, integers, strings, tuples, functions, callables. Those are all immutable data types. Booleans, also immutable. In our last stream, we learned about a couple of mutable data types. Lists, dictionaries. But today, we're going to be talking about a very powerful type of data that has become the basis for all of modern programming. The object. Right. In fact, pretty much every type of data that we talked about so far is some kind of object in Python. Objects are complex pieces of data. So complex that some programmers regard them as being dangerous and maybe overly prone to bugginess because of their complexity. But they're very powerful. They're extremely useful. And maybe most importantly, they can be used to make your code more sensible, more easy to read, so easier to read, and very, very flexible. Right. Very powerful tool. What's up, dat one dude? Why don't you put your hair back in a ponytail? I notice you keep shaking your hair back. Maybe that's why I don't do that, dat one dude. Maybe I unconsciously like doing that. It's kind of like, just kind of helps me like a nervous tick. I don't know. Probably something a cow says would enjoy, huh? What do you think of them cow bobs? Cow bobs are too godlike, dude. I was quite pleased by them cow bobs. I used to wear a ponytail back when I worked at in retail because I used to be doing a whole lot of moving around and like ducking, and it'd always be in my face all the time. I find that just being in this chair is not that bad. Okay, so what is an object? An object is a piece of data that owns, let's say owns, right? Owns a bunch of other pieces of data. It's a way of organizing data. Right? Let's define one. So, right now we have this pet's happiness, right? Pet's favorite foods, etc., etc. Why don't we make this pet into an object to organize data within it, right? Here's up, Dagger. How you doing, bruh? So we have all these things that relate to our pet, right? Maybe it would make sense to have them all be owned by one pet object. This thing that is itself thought of by the programmer as the pet. And the pet has this thing about it, you know, like the hunger level, the happiness, its favorite foods and hated foods. Let's try that, right? Let's go up here to our function, our data definition right here, defining our data for our program, and make a pet. Right? I'm going to say here, pet equals object. Now it's a new object. Okay, so we have like a little function call here. That's what it looks like, right? We have this function call, object, and it has these parentheses afterward. Right. For now, we're going to refer to it more or less like that. Right? We're going to say here, pet dot favorite foods equals lasagna and pie. Pet dot hated foods equals tofu, Brussels sprouts, black-eyed peas. Our pet's a hater, dude. It hates more food than it likes. And okra. Right? And then it has pet.happiness equals 50. And pet.hunger equals 100. All right. So now we have a new syntax. We haven't looked at the syntax before, right? What does this period mean? We'll talk about that in a second here. But first, what I can do is get rid of all these other, values we have now, right? Another redundant. Get rid of all these. Pet also has a name, right? Let's say game state pet now points to our pet. I'm gonna call this our pet, actually. We'll say our pet. All right, so to be clear what it is. Okay, we have our pet. And now he has these values, right? With this weird new syntax. Okay. Give it a name as well. Let's give him a name. Our pet dot name. We'll say pet name. Equals input. What is your pet's name? Okay. There we go. Cool beans. So here goes this here up right now, huh? Pets are objects, dude. Dude, people are objects to me. Lowercase object, says userman. Oh, really? That's weird. I think the tier list of pulling your hair back is bandana, hair tie, ears, having it in your face like a moron. Can't believe we are objectifying a pet. Better than some things. Lots of things get objectified in this world. Some people like it, though. Some people do like it. So according to my friend, userman, it's actually more like this. Object. Okay. So, it's really not a capital O? Whatever. Anyway, it's fine. So we have this object, right? That's a new syntax. So when you have an object, you can assign it values that it will then manage for you using this little period syntax. The period is like the apostrophe S in English. It implies ownership. So you could say here, our pet's favorite foods, our pet's hated foods, right? That'd be in English. But in most languages that are like programming, the period is the apostrophe S. It means ownership. Now it owns these values for us. Right? We're kind of organizing them. So basically an object is a way to organize data. It helps the programmer sort of think about their data, right? More than anything else. It's a tool for kind of keeping it organized. So now we have this pet value, this pet object, and he has these other pieces of data about it. Its favorite foods, its hated foods, its happiness, its hunger, its pet's name, right? All this stuff. And now we saved that pet to our game state as just pet. Okay. So mostly our program's the same so far, right? Except for we've kind of changed the way it's organized. Thanks for the follow. Hey, it's me, Ross. Welcome aboard, Ross. So we've changed the way we've organized our data, kind of similar to before, right? Before we had this bunch of variables, loose variables, that defined our game state. Then we moved them all to being into one dictionary, this game state. And now we have some of them being put into an object. And it's all for the purpose of keeping it more organized and making it easier for us to work with later on. So let's go through and change some things in our program. Right? We have to change some value names. We're going to do a little edit and replace all. Right? We have some things that have changed their terminology. So now we used to say we have to find game state pet's favorite foods and replace that with game state pet. That's our pet, right? And then dot favorite foods. So now instead of getting this value from the game state, this list, pet's favorite foods, we're getting this pet object from our game state and accessing its favorite foods list. Right? Remember, guys, that period there's an apostrophe S in English. Right? So before we had this list that was inside the game state, pet's favorite food, pet's favorite food, so it was called, right? But now we have this pet inside of our game state, and that pet has favorite foods. That's one stingy pet. He hates a lot of foods. That kind of bothers me, to be honest. So I'll get over it. So now we're changing that anywhere in our code. Let's go find this thing. Let's see, I want to find it, replace it, find it. It's the only place it's being used. Okay, it makes my life a lot easier. We're going to find pet's hated foods as well. Place that with game state pet favorite foods, or hated foods. Okay, find it, replace it, find it. It's the last time we ever used that as well, it seems. All good. Now we're going to find the pet's name and change that to pet's name. Or is it pet name? I think it's pet name. Okay, so let's find that and replace it. Find it and replace it. Okay, replace it, replace it. There we go, replace some stuff. Okay, it's all good. We're changing the way our code's organized now, more or less. All right. All good. Here we go. Now we want to try and find the pet's happiness. Right, it used to be an integer that was saved inside of our dictionary. Now we're going to actually save that to our pet as happiness. Right, so instead of having a pet's happiness key in our dictionary, we have a pet key, and that pet that comes returned from that key has a happiness value. Let's find that and replace it. Okay. Okay, all good. Just replace all. Let's find again. I want to replace. Not sure why I closed that afterwards. Kind of annoying. So let's also find the. We want to find the pet hunger and replace that with pet.hunger. I think we're done, right? We have favorite foods, hated foods, happiness, hunger, and pet name. Yes, so we're done after that. All right, let's find and replace, and then find, replace, and then just replace all. It's all good. What of happiness? This pet's got a happiness level, man. He starts off as being kind of middling happy at 50. Okay, cool. So it's all good, it seems. I'm actually going to do a hanging indent here. Talked about that before as well. The hanging indent's whole job is to not have it go off the far right of the screen. We have this kind of, could probably use some too right here. Right, let's just knock this down. It gets knocked down, but it gets up again. You're never going to keep it down. There we go. Who else needs some more... who else is too far to the right off the screen? Now, let's see here. Anything else scrolling off? Who's scrolling off? Right here. Okay. That gets knocked down. Reorganize this, make it a little bit cleaner. Excellent. That could be an F string as well. All right. Let's make this into an F string, shall we? I'll go back here and say F. Put the thrown object in here as a variable inside of our F string. And say wow. No, not really, it's fine. There we go. All right, cool beans. Cool fucking beans. All right, so let's see if the code still runs. We changed a lot of things, right? Let's see if it works. I changed a lot of names and shit. Run it. No. Continue. Oh, I see what's going on here. Okay, that's fine. I gotcha. Run it. Glorious Python. So beautiful. Not really that beautiful, though. Favorite foods. Doesn't? Let's see here. So I can't define a new... Yeah, I don't usually define objects this way. That's fine. I'm gonna try with a capital O. Run it. No. Oh, okay. I was kind of hoping I could just get away with this real quick, because I don't usually define objects this way, but I'm kind of confused what's going on here. Heavy petting. It has no attribute favorite foods. Yeah, I'm trying to define it. Okay. Well, I'm going to try and be lazy, then I don't want to try and solve this problem right now, so I'm just going to do this real quick. There. Ignore that, guys. Don't look at the man behind the curtain. Okay, let's see here. Alright, so this should run now, I hope. Okay, so what's your pet's name? We'll call him Zanzu. Vencabot, what was that server script for me? Or were you going to poke a hole in your router and host this? That was for you to look at, right? I'm not going to host it. I could. Pet's name. Yeah, I don't want pet's name. I want, up here, yeah. Yeah, up here. You want to feed, it's not a pet's name anymore. Now it is, game state pet. I just want to show you how it's done. I want to show you how it would be written. I think that was your question, right? Pet name. Save that. Run it. Zanzu. Do you want to play with Zanzu? Hell yeah, I want to play with Zanzu, man. Okay, end turn missing game state. Let's go down here and add the game state to this. Forgot to add the argument it needed there. Alright. Run the module. What was that man behind the curtain thing? That's because I had a bug here with trying to make a new object. And I thought I could make an object that way. Apparently I can't. Right, I thought I could make an object that way, but no one ever actually does that. I thought it'd be easier to teach as for beginners to do it that way. But apparently you can't do it that way. So I'm going to do it the way I would normally do it. I'm going to explain how it works later, though. So I have a pet now, right? It's a pet. It's an object, essentially. It has these values about it. Let's try this here. Let's call this guy Here Goes. I want to feed Here Goes. It's my fetish. I want to feed him some grapes. Okay, he doesn't really like grapes. Seems kind of hungry anyway. It sounded like something out of a spy novel, huh? That's a quote from Wizard of Oz, I think. He's hinting through code on how to save this man from the true Vencabot. Here Goes fucking hates grapes. Let's feed him something really good then, like pie. Everybody likes pie. He's in high spirits. Okay, I think the code works more or less now. It still works like it used to before. You know, we kind of have like, it's a turn-based game. We can choose what we want to do with them. It's, you know, its happiness goes up and down. Its hunger goes up and down. That's fine. So let's talk about what we've changed mostly here. Let's kind of review. So we have this pet object. And objects have things about them. Right? In this case, he has favorite foods. He has hated foods. He has happiness, hunger, and a name. Right? And right now, that doesn't really help us all that much. But what's really cool about functions, what's really cool about objects is that not only do they have data about them, such as you know, their name and their favorite foods and whatever, but they also can have functions attached to them. In this case, we're talking about things like, you know, feeding the pet. Right? The pet can actually eat. It can do things. Aside from just having things about it, it can also do things. So let's talk a little bit about classes, right? Let's go here. In Python, and most other programming languages, you know, I'm going to say object-oriented programming languages, ownership of data and functions is expressed using the period. Right. So if we were to say something like pet dot, let's say, Vencabot dot real name equals David. What we're saying is that Vencabot has a lot of data about him. But one of those pieces of data is his real name. And it points, to a string representing his real name. Right? We could also say, Vencabot dot travel to, grocery store. Right. So now, Vencabot, the object Vencabot has a function that he owns that defines what he does. Right? He goes to the grocery store. Data that's under the ownership of an object is referred to as an attribute of that object. Functions that are under the ownership of an object are referred to as methods of that object. Right. By making effective use of attributes, I'll say objects, attributes, and methods, we can make our programs much easier to read and much easier to write. Which means that we can make more complex, more powerful, and more flexible programs a lot easier. To that end, why don't we look at our code, our existing virtual pet code, and see how we can reinterpret what we've accomplished so far in the context of object-oriented programming. All right. Breaking ideas up into objects, which can have attributes that describe them and methods that they do. Right. Maybe his head shaking is like Morse code, huh? Left, 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 right, 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 left, left, left. SOS. I ain't that deep, guys. Don't read too deep into it. Or it's a little bit twitchy. Okay, so we have this pet, right? It has attributes. But what's really cool about this is that we can also make more than one pet now, right? We kind of know what pets have, right? We know that pets have favorite foods and hated foods and happiness and hunger. Why don't we talk about classes real quick, right? But before we start breaking up our code, right? Before we start breaking up our program and making it more object-oriented, we should probably talk about classes. Classes are the primary way that objects are manufactured. Right? They define what a type of object might have in the way of attributes and methods before it's even created. Right? For instance, let's say that we wanted our game to have two pets. What would these pets have in common? Well, we know that they have these attributes, although they might differ between pets. Right? We know they have, pets have a favorite food list. Pets have a hated foods list. Pets have a pet name. Pets have, I use pet name because the word name in not only Python but in other languages as well is kind of sacred. Lots of things have names. Variables have names, functions have names. So I say pet name here because it's a pet name. It's not really like a name like for a variable. It's a pet name for the actual pet. ... .. Pets also have they have foods they hate, foods they like. Their pet name. They have a happiness level. They have a hunger level. So, by defining a class that defines what makes a pet, we can make it very easy to create a ton of pets in our game. Let's do that right now. In fact, I've already gotten started. All right, so up here, we have this pet class that I made. Right, we talked before about how when you use the term pass in Python, it just means don't do anything, but it's for when you have to have something indented, right? So just like with functions, when you define a class, it has to have some kind of indented code. So I put pass there to say, just make it a really generic object. It doesn't have anything special about it right now. It's just a simple object. However, we can define some features of the pet right away, right? We can find, let's actually call this our pet. Right, and our pet, it's got a pet name. Right, it's gonna always be Zanzu. We've got favorite foods list. Right, it likes pie, and it likes what else is really good in this world? Like a cheeseburger. Right, it likes pie and cheeseburgers. Who wouldn't? And it's hated foods. Right, it hates mushrooms. It hates olives. Right, it hates these things, and it has a happiness level. Starts off at 50. We'll call it happiness, right? And it has a hunger, which starts off at 100. Everybody remember those little robots that ate quarters? They were cool in the late 80s. I had one in the 90s, and it was awesome. They were quite adorable. Can a quarter be a food? Yeah, if you eat it. Right? So I have trouble with my friends say to me, hey, Vencabot, that candy bar ain't food. I'm like, well, if it's food, if it's not food, then how am I eating it? Right, think about that. Use your fucking brain for 1 second. So I defined our pet. Right, it's a class. And now simply by calling this function right here, our class name, our pet, followed by quotation marks, parentheses, we have created a class, an object from this mold. Right, so you can think of, classes as being molds for objects. Right. The class itself defines what the object will be. And when you use the class name, followed by parenthesis, you manufacture an instance of that class. The instance represents an object that was created from a class. Right? Again, the class is the mold. Look up here at our mold, right? It says that our pet has these things about it. Right? It has a name, Zanzu, has favorite foods, hated foods, happiness, and hunger. Right? And then when we call that function down here, we call that class, it makes us an object with all these values about it. Right? Kind of cool. We can run this code now, it's going to run exactly the same as it did before. Yeah, so you want feed to play with Zanzu. Right, the game starts, you already get to feed Zanzu. It's kind of cool. We can feed him. He likes cheeseburgers, right? Give him a cheeseburger. There you go. He's in very high spirits now. That's good. Okay, so another way to do this, it makes more sense. We're not going to go into this too deeply today. But another way to kind of add attributes to an object is to call this method. Well, fuck it. Let's actually do a method first. Let's make a method here called dance. Right. Let's say here, define new function inside of our class. Right. Define dance self. Okay, and what does that mean? That's new. Right, so it's a first argument to self. We're going to say here, print off an F string. No, that's fine. We'll use regular syntax, regular concatenation. We're going to say here, self.petName plus does a dance. Okay. So now our class has attributes, right? That has these data things about it. It's all data about it that describe our pet. Then it has a method, a function, something it can do. Okay. So previously we thought of functions as being things that our program does, right? You have, like, conceptually speaking, a function is something your program does, something that you as a programmer can do by calling that function, right? But we talked before about how objects are conceptually their own thing. They have attributes that describe them, and they have methods of what they can do. Right? We're going to see why it's important here to make that distinction. So let's go down here to our bottom of our code here. Now, we made a instance of our pet, right? This is our class. We made an instance of it. We used it to manufacture our pet. Okay? And now it has data about it already, because it came from a mold. But also, we can have it dance right away. Watch. Our pet.dance. Notice here that when I call it dance, it has no argument there. Even though up here it did, right? When we defined the function, it had an argument itself. But I'm calling it, I'm not using any arguments. Okay, let's see what happens if I run this. It says Zanzu does a dance. So by calling our pet.dance, Zanzu does a dance. Okay, so what does that mean? Let's go up here and look at this again. So we called our method the same way we reference attributes, using the syntax. The object name, we gave it, dot, that's an apostrophe S, and then the function call, right? So dot means an apostrophe S in English, right? That's our pet's dance function, or in this case, our pet.dance is a method. It's a function owned by an object. All right, let's go up here and look at it. So here's what's crazy. I'm going to make a note here. Right? What's really powerful about objects, about attributes and methods, is that when you have a method that's owned by an object, it has access to all of that object's attributes and methods. Right? We talked before about how functions can only access the data that's given to them as an argument. Right? This makes writing them kind of a pain sometimes, because you have to explicitly give the function every piece of data that it needs to do its job. We kind of solved that problem, right? We kind of solved that problem by explicitly giving all of our functions the same massive, mutable piece of data, the game state. Right? It simplified the arguments that we had to give it. But it didn't do much in the way of organizing our code, because, not every function in the game needs access to every piece of data in the game state, right? If I give a function the whole game state as an argument, it doesn't make my life any easier. When I want to glance at that function real quick and decide what sort of data it needs and what sorts of data it's changing. Right, that's the thing about this way we did it before, right? We can't really tell what these functions are doing. Right? We're giving them this one big game state argument, and we know that it needs something from that game state. We know it's probably changing a few things. We're not sure exactly what. What's cool about objects, right? What's cool about objects is that we're assuming that because all of their attributes are related directly to that object, and because all of its methods are related directly to that object, it's pretty safe to assume that it needs to know the attributes about itself to do its job. Right? So for instance here, we see dance. So every method takes self as the first argument, always. And self points to the object that's calling the method. Right? So down here we say, our pet.dance. Dance is a method of this our pet object, right? So by virtue of being a method, by being different from a function, by being owned by this object, dance actually has access to all the attributes of this object. It knows what called it. Right? It gets that as self. Even though you don't actually call it with self, right? There's no argument there. but it knows self. It gets it right here, right? So we can actually call self.petName inside of that function, and it knows the name of the object that called it. We can also say, we can use pet.hunger, we can use self.happiness, we can use self.hatedfoods. All these things can be used in any method of our pet. Here's up, Infi. Infinoko, our man from the land of the rising sun. Prepare for the earthquakes and tsunamis that come in. Good vibe. What is dance? He knew it, huh? Sounds like a dancer. He's a private dancer. He dances for money. He does what you want him to do. Okay. So, awesome, right? We know about methods now. We know about attributes. So right now we have some functions that would probably make sense to turn into methods, right? Such as feed pet. When you feed the pet, its happiness goes up, its hunger goes down, and it does these, it kind of responds to you in certain ways, right? Think for the follow, Will Cola, 17. 17 is my lucky number. I respect that. Welcome aboard, man. The sun has risen, and I have not slept. Unfortunate night for a curse, huh? Castlevania 2. So what time is it now over there in Japan, Infi? Around 11 a.m. according to K-Rag. That's crazy. It's only 9:19. That's still really crazy. Hopefully you don't have any work. That'd be really bad. So this feed pet function, what if we made that a method of the pet? All right. So I'm going to say here, eat. Right? Our pet can now eat. And it's going to take self as the first argument always. Right? It's a method. They always take self as the first argument so they know what their own stats are. And then we can say, food. Give it some food. It's going to eat some food. And now we're going to copy paste our code down here from the feed pet code and readapt it to being a method. All right, there we go. Awesome. That doesn't hoard food, now it eats food. What's going on with you cats, huh? We're just doing some programming here. Talking about, the basics of Python. In this case, about object-oriented programming, finally. About why we program with objects and not just with a bunch of random functions. So far, it's been mostly just random functions. Okay. Waiting for that Minecraft. Minecraft. I can play Minecraft with this, Infi. You're probably sleeping by then, I hope, though. Let's indent all this code now. Now, they can actually, I think I can use some kind of tool for this in this program. Idle. Let's see. Can I format this? I'm going to indent the whole region. Boop. Did that work? Seems like it did. Okay, cool. I think that kind of worked. It's going to be a lot of fun tonight playing some Minecraft. So now we don't know the game state anymore. Right, but that's fine, because we've been referencing most of the game state stuff in here is referring to the pet. Game state pet. Right? But now we know about the pet because we are the pet. Right? We can use self now. So we can say here, if food in self.favorite-foods. Right? We know about ourself. We don't know the game state, but that's fine for now. We can say self.happiness. Yeah, plus 20. Self.hatedfoods. Self.happiness. Right? We know we're changing values about ourself now. Now, objects are mutable, guys. I want to point that out. I think I might not have mentioned that earlier. Okay. Shout out to all the pair. All right. Self.happiness. Maybe with some of these memes in here, it's a little bit crowded. Okay. We have a pet name, right? We're going to say self.petName. Eats the pet food. Happiness goes up. Okay. Awesome. Okay. Awesome. So now it becomes more clear what our pet is doing. because it no longer takes the whole game state to feed it, right? Now when you feed it, all it needs to know is the pet food, because the pet already knows the important things about itself to get this job done. It doesn't need to know, you know, if there's poop on the floor when it's eating, right? Unlike me. Here we go. We reduced the hunger here. Okay, awesome. Get rid of this pooping code for now. I'm gonna make a separate function. I'm gonna make a separate method here called poop. Right, let's leave that out for now. Try to minimize how much we have to know the game state. Okay. There we go. So now the pet can eat food like this. So we go down here to our feed pet function. We can change how it works. We can move all this code away for feeding the pet. Right, all this code right here, actually. And now we can say here, we save the pet's food. What do we want to feed the pet? Now we're going to say here, game state pet, that's our pet, dot eat pet's food. Boom. Simple. Okay, so now we're going to feed this pet's food in a more programmatic way. All right, now the pet can take this food in with the eat method. Right, we ignore the first argument, which is self. Right, it takes the food in, and it changes its own happiness and its own hunger based on the food you gave it. Right, now it manages itself, which is a little bit more clear. Now we go down here to our feed pet code again. Now when we feed the pet, we ask the player, what do you want to feed him? And then the pet eats it. See? And then if the pet is, you know, not hungry, it takes a shit. Right, which is fine. We're gonna Tamagotchi, yeah, Infi, we are. I'm missing the chat here. Minecraft requires effort and time. It takes at least time. I don't know about effort. It takes a lot of time. Like Tekken or 3S, but you can't beat people up so as hard. I don't know, man. So in Minecraft, you can blow up somebody's house. That hurts a lot more than anything that happens in Third Strike. He's making a pretty deep pit, huh? We're gonna Tamagotchi, basically, yeah. We're kind of using this as an example to learn Python. It's a virtual pet. Okay, so now we have this pet object, right? And now it can eat. Let's make this play with, right? Maybe we can have its own play code as well. Here's our current play with code. It asks the player what they want to play fetch with. Then it plays fetch with it. Why don't we go and take all this code and grab it out and make a new method of our pet that's play with. Here's what a cow says. Looking for the raid, dude. Moo. Where are you playing, man? Some Minecraft or something else. Let's make a new method called play with self and then a toy. Or give it a toy to play with. Let's paste all of our old playing code. Right. A little bit sloppy. I don't like to scroll. I'll use this to scroll. It makes it a little bit easier to read. Okay, let's actually indent all this code now. Oh, I missed something right here, I think. No. I missed the first line when I copied this. Where is it? Where's the play with code? Right here. I missed this line. I'm a doofus. I'm the world's stupidest man. Okay. Oh, here it is. Wow, I am really stupid. Boop, there we go. Like that. So let's indent all this code now to be inside this method. Okay. Format. Indent region. Boop. There we go. Elite Dagger. It's a space sim. So this Elite franchise is a pretty popular, like, European space game franchise, right? But I hear they're all pretty different. Like, some are more like shooting games. Some are more management-based. Are you enjoying it so far? So we have this play with, right? And once again, we don't need this game state pet. For all that, we don't even know the game state anymore. What's cool is that we don't have to know the game state to play, right? We know ourself. Know thyself. We know our own happiness level. We can change that too. We know our own pet name. It's really time involving, man. It's like an MMO, right? But you say that it's a simulator. Is this a single player game? Or are you playing an MMO? I know some of them are MMOs. We know our own pet name. We know our own hunger here. All right, self.hunger, self.pet name. You can change your own happiness, just like in real life. Okay, so now we have this toy. We're not going to ask for the toy when we play with now. We're going to simply assume we have a toy already, and we call that the toy, right? It's an argument, right? Play with the toy. Let's say here, you throw the toy. I can use an S string for that too. Right. We'll say here, F string, you throw the toy. Less concatenation that way. Here we go. I got you, man. Have a good day, Cow says. Let's see here. Big learning curve. It's an MMO, okay. Has solo and private groups. I gotcha. Envy says, since this is programming stream, shouldn't the cow say a bunch of binary? It's gonna be stealing that one, huh? Have a good night, Cow says. Hopefully you enjoyed your game. Sounds like it's pretty long. Can be probably a little boring sometimes, but hopefully it ends up being worth it. Have a good rest, man. Okay, so you throw the toy. Right now the pet's happiness can change, right? Or we say that it's based on the pet's happiness how fast it responds to you throwing the toy. Use an F string here. Self.petName retrieves the toy with lightning speed. A little bit too long. That'll do. That binary says moo, okay, in ASCII. Invinoka with the only CPU speak in binary. They use an Android. To find out if he poops or not. Because if they don't poop, they're an Android and should be destroyed. Alright, so we got more F strings we could use here. Make it a little bit simpler for us. Alright, we have a self.petName now. Make an F string. We'll say takes their time. They're retrieving the toy. Too long. Okay. Everybody poops. And if they don't, they're an android. And should be destroyed. There we go. Awesome. Always hated assembly, huh? I'm sure my friend Ryan's probably programmed assembly before. Though in the early shitty days, they did program computers in binary, which led to assembly later. I never once played around with assembly. Should have taken advantage of learning this stuff, huh? What do you mean, Yun? Go check it out on YouTube as well. The archives are all there. It's really powerful, dude. It's a lot of fun, too. Programming's very creative, very satisfying, at least for me. I'd be surprised if it wasn't for you as well. More F strings here, make it a little bit simpler. We can also use self. I need to put some brackets here, though. There we go. Push onto the stack, pop off the stack, huh? I'm usually popping off the stack in real life after the stream ends. Alright, let's see here. So, a pet's name watches the toy fall and looks at you dumbly, right? There we go. Okay, sweet. And now we can raise pet's hunger because it played, right? When the pet plays, its hunger goes up. Sweet. I'm actually going to get rid of some of these blank lines now. It's going to be a little bit tough to scroll through. And it can be more. So basically, the more clear we make our programming, the less blank lines we need. That's another thing I find about self-commenting code. You want to write your code as cleanly as possible. At that point, you can condense it. You want to keep it as condensed while also keeping it easy to read. In fact, sometimes having it be more condensed makes it more easy to read. Push on, pop off, bite, bite, bite. Programmers cheer. Wow. Okay, so now we have this play with toy method. First thing it does is ask if the pet's really unhappy. If it is, it's not in the mood to play. Then the function ends. Right, the method ends right there. Return. If it's too hungry to play, then not only does it not play with us, but it gets less happy because you wanted it to play with it while it was hungry. Right? You wanted to play and it was still hungry, so it kind of pisses it off. All right. Then we can throw the toy. If those are not true, right? We get down this far, it throws the toy, and then if the pet's happy, it plays more enthusiastically. If it's unhappy, it plays less enthusiastically. Then it becomes more hungry because we played with it. Right. Sweet. Okay, that's our entire code for play with. Now let's go down here to our function, play with pet. Right. What we do here is we're going to very simply ask what you want to throw. Get the thrown object. And now we're going to call the function, the method. We're going to say here, game state pet dot play with thrown object. Right. So now this pet can play with a thrown object. You save what you want to throw, and then you throw it at the pet. And you throw it not at the pet, but you throw it for the pet to go fetch. Is there a 100 chance it'll dance or getting its favorite food? That's a good idea, dude. Let's go add that. Although we don't have random yet. Let's go up here. Let's just make it dance in general, right? Get its favorite food, we're gonna have it dance. Right, self.dance, right? Because it knows itself, it can use its own methods, right? It has this method dance. We know self, so self.dance. There you go. So now our pet has attributes about it, its name, its favorite foods, its hated foods, its happiness and hunger, and it has methods, things it can do, like eating food and playing with toys. All right, cool. Now we can use this to our advantage down here by making these functions a lot simpler. That could be added. We'll probably do that next time. I want to work on importing libraries at some point, but classes and objects is such a rich topic. I don't want to get too far into libraries right now. Okay. Then do an F string, why don't we? Change those to not end the string. There we go. Okay. So here's the thing. When the pet poops, I want poop to be a method of the pet. It makes sense, right? Pet.poop. Because the pet's the one that's doing the pooping, right? But the thing is, it needs to know the game state to know what floor to poop on. So let's not have that be in there yet. Because basically, when you're talking about objects and classes, we talked earlier very briefly about the danger that comes from giving a function too much information. Right? Because then when you're scrolling through it very quickly, it's not sure which of that data is being used in that function and what's being changed by that function. This is the curse of mutable data, the curse of object-oriented programming. It's that you don't really know what's going on sometimes because you're not sure what data from this massive mutable object is being used and changed in each function. So what's really cool about object-oriented programming, like making classes and stuff, is that we know that when you're calling these methods, right? You're calling this method like dance, for instance, right? Very simple method. It only takes no arguments. It just uses self. We know that any data this method is messing with belongs to that object that's calling it. Same with this feed, this eat function, the method, right? It takes one argument, which is food, which is a string. That's immutable. So we know that by feeding our pet, we are not changing anything else in the game that's not related to our pet. Right? So we're kind of managing now how much data our methods have access to, which makes it more clear how they work at a glance. Same with play with, right? Play with only takes a string, a toy, to use. So we know that anything this thing is changing belongs to this pet. Welcome aboard, Trambo. Nice to meet you, man. I'm David. Pleasure having you. Wish I could use Python more at work, says Ryan. If you make poop an object, it'll get garbage collected. What a bonus. Wow. The puns are too strong. How is this a tutorial for total beginners? Well, because it's a series. If you go back into our YouTube channel, we talk about first-time programmers. It's season 5 right now, season 4. Every season has 6 episodes. So go to our YouTube channel. Our episode 1 is always for, like, what is a program? What is a variable? How do I make a function? And then by episode 6, we're on 5 right now, where it's some relatively advanced type stuff, talking about objects. What's up, Katie? What is poop? What is poop? Always talking about poop on this channel. Okay, so we're playing with our pet, we're feeding our pet, and now we have this object that manages all this data itself, right? Now, if it poops, it has to change the game state. So for it to do that, I need to feed it the whole game state as an argument. I'm not sure I want to do that. How much time does it take for me to get to this part of your tutorial? A week of every day going, exactly. So most of our episodes are around 2.5 hours long, and there are 6 episodes per season. And we're on episode 5 right now. If you go to our YouTube channel and go watch, let's say, season 3, it'll take you probably around like a little more than 10 hours to watch the entire thing. But I'm confident that in that time, you're going to be learning to becoming a pretty strong programmer. I'm pretty proud of the pace we move at. I think that if you're in a hurry to learn to be like a game developer or a programmer, it's a pretty good way to learn. Yeah, just watch it 2 times speed. That'd be fun. With the chipmunk voice. People order our patties. Quote SpongeBob. Yeah, programming is it's taken me 20 years to learn to program, but I'm trying to help out people to learn a lot faster than that. Can you learn enough to get a job if you watch your tutorials? Yeah, although they might ask for some kind of credentials. You can't just say Vencabot taught me. That probably won't fly. But yeah, you'll be skilled enough to definitely work in the field from watching tutorials. After watching our 6 episodes of any given season, you should have enough skill to write your own code, be confident in your own software, and maybe even get a job doing it. But again, I think they're going to have to have some credentials, though, in most cases. Yeah, I talk pretty fast anyway, even without 2 times speed. Okay, so let's not worry about pooping too much right now, just like in real life. So we have these functions here. Okay, play with the pet, put it back to bed. Okay, clean up poop, cheat in the game. Okay, end the turn. It's all well and good. I'm getting into Python, Django, Git, and Docker. Django is super powerful. I don't fuck around with that much. I love web design, but I kind of keep them separately in my head most of the time. The actual web design in Python, I keep them more or less separate. I like to call CGI scripts in Python, but don't fuck around with Django. I hear it's pretty powerful, though. Practice, 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 yeah. Maybe one day, Katie, that Vencabot certification. Just call me on the phone. I'll be your reference. Yeah, well, who the fuck called me right now, dude? I have a potential employee here, Trambo. He says you taught him Python? Oh, yeah, he's a real good guy, real smart dude. Definitely hire him. Thank you for your time, sir. You're in. All right, so let's see here. So we've talked a little bit about classes now, and objects, and methods and attributes. Awesome. And the way we can use them to make our code more organized. Right? Because now we know that when you call a method of our pet, it doesn't need to know if there's poop on the floor. It doesn't need to know, this or that and the other thing. All it has to know is things about itself, which is awesome. So now why don't we talk... What's a good place to sort of bring this to now? Why don't we make a new kind of class? Add a new feature to our game. Can you run this in between? I just don't get it. If you make a new function, how does it know it if you run it? Did you have some library behind that? So what's going on here is that we are defining our classes and those classes' methods and stuff before we're ever actually using them, right? I'm not sure if that was ever clear. That's a good question, Trambo. So basically, programs read top to bottom, right? Except that indented code does not always run top to bottom. So really, this code here, it only runs, essentially, when we create an object of this class. Right? So we have the class defined right here, and we define some functions right here. Right? These functions are being defined by us, right? To make our game work, essentially. But they don't actually get called yet. So these things actually never happen. All this code here doesn't actually happen right away. So we're defining a bunch of functions here, feeding the pet, playing with the pet, putting the pet to bed, all these functions we're making here to make the game work. Right? Clean up poop is a function for cleaning up poop for the pet. Cheating is a function in our game. I know Katie would like that. Ending the turn is a function. But here is where the program actually works. Right? It's very simple insofar as the actual way the program runs. So we define our pet from our class. It's based on our pet. Then we define the game state. Right? It's got this couple attributes about it. We have a pet in our game. We have a poop on floor value, and we have a value that's telling us the game's still running. Then our pet dances. Make some commands here. Run the game. Input pet activity. How does it know that function? How does it make the game, though? Like, what's behind that function so it knows how to execute it? It's Python's behind it, Trombo. That's the idea. So Python, or any programming language, it's a set of tools that you can use as a programmer to talk to your computer. Right? So basically what happens here is I have this notepad file. It's literally just a notepad file. That's all there is to it. It's just plain text. And then I run this code through Python, and Python reads it line by line and translates what I wrote to give the computer some commands. That's how it works. So your question is kind of like, if I look up here at my input, pet activity, right? This is basically code that I wrote, in more, it's kind of like English, right? You can see the English words in here. It's kind of like English. It's Python language. And then the program Python reads this code and then makes the computer do what I asked it to. That's how it works. So I write code, and then Python translates it to computer language, and the computer runs it. I'm using idle, yeah. However, PyCharm shows me better what's my error when it executes it in the shell. That's kind of nice. Hey, Venk, quick check before I do something. How long is this section is there left? There's going to be a little less than an hour left of Intro to Python here. Get that Minecraft, KD. Okay. So, again, why don't we make a new class here? We're going to add a new feature to our game using objects. Why don't we add a food class? Right, make a new class at the very top. Doesn't really matter what order they go in. Class, I'm going to call this pet food. Okay. So what does pet food have about it? It has like a nutrition value. Well, like a tastiness, right? Tastiness value. It's going to default to, well, you know, fuck it. Let's actually do something different here. I'm going to say here, def underscore underscore init underscore underscore, right? It's a method. It takes self first. It's going to take a tastiness argument, and we'll give it like a food name. We'll give it a food name first. Food name argument, a tastiness argument, and a nutrition argument. Call it nutritiousness. Right. As an argument. There you go. So it takes 3 arguments, right? Because the first one, self, is sort of implied. They're going to follow, what is that, Korean. They're going to follow somebody from Korea, huh? Somebody making good money with your skills and game dev. Hell no, bro. It's more of a hobby. It's a lot of fun, though. But it can be used professionally in a lot of fields. I think as time goes on, and we have, you know, computers with us all the time in our pockets and stuff, it's going to be more and more important to learn how to program for sure. Whether it be for a hobby or for your own automation, making your life easier, or as a job. I stream, Trembo. I stream 40 hours a week. And make not a lot of money doing that either. But it's better than some other stuff. So let's see here. I want to save... I have self, right? I have self now. I'm going to save self.foodName equals food name. So whatever the argument was here, we save that as an attribute of our self. Right? Self.tastiness equals tastiness. So we supplied a tastiness argument, and we're saving that as an attribute of our self. And self.nutritiousness equals nutritiousness. So I can definitely run it for you, Trembo. Okay. So we have this def init method. What is this init method? This method defines what kind of object we're going to get when we instantiate. What does that mean? I'll talk about that in a minute here. Thanks for the follow, Trambo. Let's run our code for the kind of satisfy Trambo here real quick. Run it. Okay, so the way our code works right now, basically, it says, do you want to feed or play with Zanzu? That's our pet's name is Zanzu. You can say, I want to feed him. Right? It says, what do you want to feed him? Okay, well, I can feed him, you know, rocks. Oh, shit. Not defined. What did I fuck up here? Pet's food. Okay, I got an error there. Let's go down to eat. We have this pet's food. I want to call this food, actually. There we go. Save it. Run it. Yeah, it's all text-based. This is more for beginners. We're not fucking around with graphics or anything like that. We're mostly sticking with the basics. Let's feed. Feed him, we'll feed him some bananas. All right. Oh, fuck. Got another typo here. Where is this? Right here. Pet's food. Should just be regular food now. That's why I don't copy-paste code, guys. Run it. I want to feed him a hamburger. There we go. So he ate a hamburger. And it says here, he's kind of down now, right? He doesn't really like hamburgers. He likes cheeseburgers, though. Let's feed him a cheeseburger. Okay, well, now he's in high spirits. Okay, let's feed him another cheeseburger. Okay, still in high spirits. Let's feed him one more time. Should become ecstatic, I think. Okay, now he's ecstatic. Let's feed him some, what does he hate? He hates olives, right? Feed him some olives. Uh-oh, we have pet's name still. Let's see here. Where is that at? Line 74. Pretty far down. Because it pooped right here. Let's see, where is that at? Run player command. No, input pet activity right here. Pet's name. I actually want pet. Dot pet name now. And then shorten this a little bit. Clean. My bad. Okay. I'm missing the chat here. It's text-based. Now I got it all, huh? I was wondering because I thought you were graphics-based. Oh, no. That's why it's so simple. Yeah, that's why it's so simple. If it were graphics-based, it'd be a lot more to it for sure. Could you understand the programming that was written for, like, WoW? If it was written correctly, yeah. We talked about how important it is to break up your code sensibly to make it more readable as it goes on. Basically, if you're a good programmer, you can make a code as complex as WoW, like a really complex program, but have it be in enough small pieces that you can break it apart visually and understand its parts. Now, maybe no one person could understand exactly how WoW works in its entirety. That'd be too much work, right? It'd be a huge program, you know, probably thousands upon thousands upon thousands upon thousands of lines. But if you want to fix one part of it, hopefully the code's written in such a way that you can find that bit of the code and understand that part, right? That part of the challenge of writing software is to make it modular, make it, you know, so that each part can run more or less by itself, and then you can break it apart and understand it individually. How can one turn code graphic-based? Use a library in Python called Pygame for one thing. Very simple. Use a library like Unity, an engine of some kind. Try Blender. Blender takes Python code to make 3D objects run and move around and stuff. They're different languages, huh? They have different keywords and underlying concepts, yeah. Yeah, different languages and engines have their own scripting language, but they're all very similar, though. I think Python's a good starting point. In Python, you can also, again, make games in Pygame or in Blender, etc. Graphics made of pixels can use colors split into 3 values for red, green, and blue per pixel. This is Ryan's field of expertise. But yeah, definitely Python's a good starting point. We're starting with text, very simple. Definitely nothing's going to overwhelm a total beginner. Okay, so this should all run now, I believe. That's all well and good. So we can feed them, play with them, all that good stuff. But now we have a new class here for a pet food, right? And this food object has attributes about it. It has a food name, tastiness, and nutritiousness. All right, so let's change how this all works. For instance, now when we feed our pet, we feed it some pet food, right? An object representing an actual piece of food, not a string anymore. Before we fed it a string, a data string. And that data string, that textual string, would be compared to a list of strings, right? Favorite foods and hated foods. We're going to get rid of all this stuff now. It doesn't have a favorite food or hated food anymore, right? Now it just has food that's tasty and food that's nutritious. All right, so let's see here. So we're going to say, instead of all this, if food in self.favorite foods, becomes happier, we're going to say here, if food.tastiness is greater than, 70, it doesn't really matter for this purposes, then it's going to dance and become really happy. Right? You get even more happiness, to be honest. We're going to say here, if, it's called pet food now, not food. We'll say if pet food dot tastiness is greater than 70. If pet food dot tastiness is greater than, 40. Then self dot happiness goes up by 15. We're gonna say here, if pet food dot tastiness is greater than 20, then, it stays the same, right? Then we're going to finally say here, else, right? Else, if it's, below 20 tastiness, it's going to actually make it less happy. Actually, no, we'll say that if it's above 20 but below 40, we'll say self.happiness minus equals 10, go down by 10. Then if it's even worse than that, it's going to be like a hated food, right? Like it really hates his food, going to lose 30 happiness. There you go. So I started studying programming in school, Python. Today we wrote rock, paper, scissors game code. It was really interesting. Awesome, dude. Awesome. That's how you're learning about like logic, right? Like if and little logic trees. I think for a beginner that is very exciting, right? Because it kind of introduces complexity to your code. It kind of has things change based on what you do. That's really exciting to me. I'm glad you're enjoying it, Olive. Oliver, not Olive. I got olives on the brain because pets hate olives. At least I do. Okay, so now we can say here, pet ate the food. So whatever, we're going to call it pet food now. And happy is all can stay the same, right? If it's really happy, it's whatever. But now the hunger is going to change based on that pet food's nutrition level, right? So pet food dot nutritiousness. I think we follow Oliver Carroll. Probably mispronouncing that name, I apologize. We do Python here every Friday, kind of like tutorials, talking about different aspects of the programming. If you want to catch up on where we're at right now, check out YouTube. From 1 to 10, how well do you know Python? I would say, like, between 8 and 9. There are some aspects of it that if I saw them, I'd still be like, whoa, what the fuck is that? There's still some minor parts of the syntax that would probably confuse me at first. But it's a very rich language. There's a lot to learn about it. Okay, cool. So we have this little bunch of, little if trees, little logic trees here. Hunger is reduced now. So basically now we've taken away this idea of food being a string, which simply represents the name of the food, to being an object itself, right? This pet food object here, it has a tastiness value now that we can compare to whatever integer we want, scale from 1 to 100 basically, and it has a nutritiousness value as well that reduces your hunger. Right? Cool beans. Also, the pet food itself has a food name. Right? Cool. Sweet. Hardest thing new programmers have is knowing how to write what they want instead of just knowing syntax. Yeah, I think that if you try too hard to write what you want, you're going to not learn as fast. I think it's more important to instead write what you can. Look at what you know and write what you can. And then add new things gradually. Going to subscribe to your YouTube channel and start watching your videos tomorrow. Good stuff, Oliver. Yeah, I've got 3 seasons that are complete now. The first season, we start off again. Every season starts off with, what is a program? What is Python? How do I install Python? And then episode 6 is the last episode, which is a fully working game with more object-oriented ideas. We started off with season 1 was a Pokemon game, season 2 was a text-based adventure game, and season 3 was a sort of an RPG, sort of like Dragon Warrior. This season's a virtual pet. We're just about to wrap up season 2. This is episode 5. It's pretty damn good. You could find a job in a good company just like that, I'd think. Maybe. Maybe. Again, there's a lot of competition out there, for sure. I definitely know enough to get a job in programming, but that's different from getting that job in programming. Okay, so now we've used objects to make the pet food more interesting, right? So let's use this init method to create some food, right? So let's go here to our feeding code. Right, well, fuck it. Let's actually give the player an inventory of food, right? We'll say here, game state, food inventory equals, make some food, right? Give the player some food to start off with. Make some food right now, in fact. Fuck this. Let's make a banana, right? It's going to be a pet food. And it's going to take in a food name, tastiness, and nutritiousness. It's going to be a banana as the food name. It's going to be pretty tasty. I love bananas. I'm going to give it a solid 70 on the tasty scale. And its hunger level that it restores, its nutritiousness, I'll give that like a 30. Not much. I'm going to give it a 20. Okay? So you can see here that unlike with our pet, right? With our pet, we put in no arguments when we defined when we created the instance. Right? That's because we had no init method. Here, see, there's no init method. However, our pet food has this init method. Basically, when you create this instance from this class, you can supply arguments that define that instance, right? So our pet Zanzu, he's always the same. He always has the same name, Zanzu. He always starts off with 50 happiness and 100 hunger. However, for pet food, we can define this food when we create it, right? By supplying these arguments: food name, tastiness, and nutritiousness. Right, not so good for my Lisp there. The food name is saved, so is this, so is that. It's all saved to self, right, when we call this method. So right here, for pet food, that init method, like this, is essentially called invisibly. When you call this, you are effectively calling the init method, right? So any function, any method in Python, or pretty much anything in Python, that begins and ends with 2 underscores is like a magical function. That means that it's called in a way you don't see necessarily. All right, so certain classes can have init methods that define how they're created. So here we're saying take these arguments on creation and save them to the object. So we have this banana now. It has these things about it. I have user experience. Yeah. 20 you said, yeah. It's a lot of time. But in that time, I'm self-taught. So I think that people that are more diligent about finding good resources than I am will learn a lot faster. Can you write tools? That's what you mean, Toastsmith. What do you mean by write tools? Welcome aboard, bro. How much better than the guys who waste time on the online certifications, huh? Those aren't worth anything because employers know you're new if you go to those. Interesting. Gotta be careful, I guess, huh? Zanzu is literally my coded twin. I'm also usually at 50 happiness and 100 hunger. Wow. Let's call him KD then. Right. That's more like KD than Zanzu. There we go. In fact, let's make this into an init, right? Let's make this into an init. Def init. Self pet name. Then we'll say here starting happiness and starting hunger. Right. So when we define our new pet, we're going to say here self.petName equals the argument for pet name. Self.happiness equals the argument for starting happiness. And it stands for initialize, by the way. And self.starting hunger. Excuse me, self.hunger is the argument for starting hunger. There you go. So now when we define our pet, we do it at instantiation. Right down here. Our pet equals KD Alpha is his name. And he starts at 50 happiness and 100 hunger. Don't sell yourself short, huh? You're pretty damn good, and you write clean Python. Thank you, Ryan. I appreciate that. I try. It's not always easy in these tutorials. I try and keep my code sort of limited in its tools as we go on, and as we go on, we kind of unlock more tools in the series. But writing clean code is kind of hard sometimes because we're kind of trying to learn how to write functions and stuff, and kind of changes as time goes. Anyway, I'm sorry, guys. So we have this our pet class, and we're instantiating or manufacturing a pet from that mold. Right? The class is a mold. We're making a new pet, and now we have an init method. Right? We can actually supply arguments to it that define how our pet behaves. You know what I mean? When we instantiate it. So I can actually call this Zanzu now, right? Call him Zanzu. Or I can call him KD Alpha. I can have him start at, 50 hunger. Or I can have him start at, 100 happiness. Right? But we can kind of change that now. So when we instantiate our pet, it saves those values, those 3 arguments. It saves them to the object, self. Right? It saves its own food name here to food name. Or our pet, excuse me, a pet name. It saves its own happiness level, saves its hunger level, etc. Kind of cool. All right, so we have this pet food now. We have the banana. Let's make more. Let's make, a pie. It's also pet food. And it's going to be called pie. It's going to have max tastiness, dude. Holy shit, it's so tasty. And it's going to have, pretty filling nutrition as well. Just like real life. Pie is very good for you. All right, we're also put in, what else is good? We'll put in, like, some mushrooms. Give them a mushroom, right? Pet name, mushroom. It's got 10 tastiness. It fucking sucks. It's disgusting. And also not that nutritious either. I mean, it's not very filling. So I'll put that at like a, a 10. Just a mushroom. We can also add in, what's other good kind of food here? I'm sorry. Yeah, pet food. Thank you, Zanzu. You caught my typo there. That would have been an error. Then we also have a cheeseburger. It's a pet food. It's, a cheeseburger. That's its name. And it's going to have, really high tastiness. Give it, it's going to be like 70 tastiness. Maybe you can even make it tastier. And give it pretty good, hunger filling as well. Give it solid 30. Okay, so now we have 4 kinds of food. Right? We have 4 foods, essentially. And let's put that into a food inventory, right? Game state, food inventory, equals a list. It's going to have banana and pie and mushroom and cheeseburger. Right? So it has these 4 things in that list for our inventory. Right? We define some food. We define the food here. 4 pieces of food. Put them onto a big list. Right? Food inventory. So now we're going to change the way we feed our pet. Go to our feed pet code. right here. So before what it would do is to say, what do you want to feed pet's name? So what do you want to feed Zanzu? What do you want to feed Katie Alpha? And then it would take your string and feed the pet that textual string. If I typed in the word cheeseburger, it would feed the pet the word cheeseburger, right? But that doesn't work anymore. Now the pet takes an actual piece of food, an actual food object. So we're going to say here, instead of asking what you want to feed him, I'm going to say here, for a for loop, I think maybe our first for loop, for pet food in game state food inventory, right? Print pet food dot food name. Okay, so what does that mean? Watch this. I'm gonna say here, print. You can feed the pet, right? And then it goes through this list. So we learned about while loops, right? Now a while loop is a loop that will repeat over and over again until a condition becomes false. Right, let's go down here and look at our while loop. It says here, while we're taking care of the pet, keep running the game. This is the whole game right here. So while we are taking care of the pet, keep running the game. Once this statement here becomes false, once we are no longer taking care of the pet, the game ends. Right? If the pet bites us, it's game over. That becomes false. If we choose to put the pet to bed, then that becomes false and the game's over. Right? But we have a for loop as well. Now a for loop is different. It will loop over every item in a list. Once its list is exhausted, then the loop is done. So look at this, right? So our food inventory is a list of food. Right? It has four items in it, right? And they're all pet food object. Right? So we know they all have a food name, right? Banana, pie, mushroom, and cheeseburger. That's their string, right? So we go up here to our feeding pet code. It says here, for every pet food in the food inventory, print off that pet food's food name. So it's going to go through every piece of food and print off its name. So it'll say, you can feed the pet banana, cheeseburger, mushroom, pie. Right? Not in that order necessarily. I forgot the order was. But anyway, it's going to go through every item in order and print off its name for us. Then we're going to say here, it's going to be a little bit complicated. It's fine. Yeah, it's all right. Let's say here, what do you want to feed the pet? So we'll say here, chosen food equals, what do you want to feed the pet? It's going to be a string. So how do we get this item out of the inventory by using its name? Right? It's going to be a string they want to type in, right? Well, here's my idea. My idea is to take that list of food and make it into a dictionary. Right? We talked before about how dictionaries associate one kind of data, let's say a string, with another kind of data, let's say a food. Right? So watch what I do here. Before we do anything else, I'm going to say, this is our first line in our feed pet. I'm going to say here, food dict equals an empty dictionary. I'm going to say here, for pet food in our food inventory. Another for loop, guys. I'm going to loop through every kind of food, right? I'm going to loop through all the food in the list. Food dict pet food dot food name equals pet food. Okay? It's a very short little loop there that's very powerful. What we're doing here is we're taking this empty dictionary and we are adding keys to it. We're saying use this pet's food's name as the key, and the value that key points to is the pet food itself. So now the word cheeseburger refers to the actual food that is the cheeseburger. Right? So we have this, we're kind of adding things to the dictionary as we loop through this list. For every item in this list, right? You can call this whatever you want, right? We'll say here, for each item or whatever, right? For each item, doesn't matter what you call this. That's just a variable name. For each item in this list, then we're going to say here, that item's food name is the key in the dictionary, and the value is the actual object that we got out of our list, right? So basically, when you do a for loop, you're saying here, define the variable name you want for whatever item you're at in the list, right? Then you can use that item in the list in your code. So this loop goes through every item inside this inventory, one at a time. Starts with the first one, goes to the last one. And then each time, it saves that object in that list under this name you chose. Each item, or we can use pet food, whatever we want to call it. Right. Then we can use that object inside of our little indented code, our code block. Right. So I'm making a dictionary here, looping through this list. So now our result is a dictionary where we have a bunch of keys, which are strings, which are the text that represent that kind of food. So we have pie as the text, then it points toward this pie, which is an object, right? It has things about it. It has nutrition, it has tastiness. And we also have, cheeseburger, that points toward the actual cheeseburger. Right? That's what a dictionary does. It's like a map. It maps one thing to another thing. In this case, a string to a piece of food. When I say string, I mean text. That's a programming lingo. So now we have two things. We have a dictionary that has a list of strings, which are the food names, pointing toward the actual food itself. And we have, the player now knows what the names of are the food that it has access to. Right? We know that as well. So now we can put that all together and say, hey user, type in some text and I will get the food you want because I have this dictionary that knows what the food is for the word that it is. Right? We have the word and we have the food and they're associated. So you can type in any word you want now, I can give you that food. That's what we just did here. Again, very few lines of code, but very powerful. Right? I'm gonna say here like chosen food and name, right, is what they typed in. Input gets input from the user, right? Textual input. So they give us a chosen food name, and our chosen food, right? Chosen food is equal to our food dict at the chosen food name, right? Because they chose a food from that list that we provided to them, and we have this dictionary that points the names to the foods. So our chosen food is whatever our food dict gives us back for that chosen food name. Right? It might be a key error there because they can type in the wrong kind of food and crash the program. It's whatever. They can crash the program by typing in the wrong kind of food. That's fine. So now we can feed the pet the chosen food. Right? Cool beans. Let's see if this works. I doubt it, to be honest. Here's another thing, guys. You guys are programmers, like newbies or even experienced programmers. If you change a lot of stuff and then run your code, there's going to be a typo in there somewhere. We'll see how it goes. Sounds like I'm feeling kind of rigid. What? You had a bad sleep? I always feel stiff when I get a bad sleep. Run the module. Okay, so we don't have this value here. Nutritiousness is not defined. I fucked it up. I misspelled something. Nutritious. I think I misspelled it with an I there. I'm not even sure how to, I'm going to call this an easier word. Let's call it, fillingness. Right? It's really what it is. Fillingness. It's how much it fills you up. It's not really nutrition. Easier to spell that way with my stupid ass. Let's go down here to the actual food here as the fillingness now. I'm filling myself. Like my ex-girlfriend used to do back in the day. Run it. Do you want to feed or play with KD Alpha? I want to feed him, man. He's been a good boy. There's some food. So you can feed the pet banana, pie, mushroom, or cheeseburger. So again, guys, it went through this list, right? It went through my list, and it printed off every name. Right, let's go here to our feeding code. Feed pet, right? So right here it says, you can feed the pet, and then it prints off every food name from that list. You can feed the pet banana, pie, mushroom, or cheeseburger. We want to feed KD Alpha. We can crash the program. We learned that, right? I can feed them, let's say, I want to feed them cherries. Boom, key error, right? So what is a key error? A key error means you try to put in a key into a dictionary that dictionary did not have in it, right? So our dictionary only has, banana, pie, mushroom, and cheeseburger. It does not have cherries. We get a key error there. So let's actually put that into a try block, right? So try to get the food out. Go here, excuse me. You can try to get the food out, but it might not work. And if you get a key error, we're going to accept that instead of crashing. Right? Accept key error. Don't crash, but handle the key error. And say, print off, you don't have that. There you go. Done. Return. End the function. Right? We can't feed him anything, so return, end the function. Let's try it again. Run it. I want to feed KD I want to feed him cherries. Okay, you don't have that, it says. He seems kind of hungry. So all right, I'm going to feed him again. I want to feed him a cheeseburger. Okay, so he ate a cheeseburger. He does a dance. Right? Then he seems in high spirits. Right? So basically, the cheeseburger made him dance because it was very tasty. Or if I feed him mushrooms, he's going to be very unhappy with me. Right? Because he doesn't like mushrooms. They're not very tasty. Hey, good stuff, Mike Pro. From Korea, learning Python at the moment. Good stuff, man. If you have any questions, let me know. I know I talk very fast. I apologize. If English is not your first language, that might be kind of hard to understand. But welcome aboard, dude. He hates mushrooms. He's going to down, right? So basically, our pet likes tasty food. Let's go up here. To our pet, right? When the pet eats, right here, there's where the pet's eating, right? If he eats tasty food, he gets more happy. He dances right here, becomes more happy. And here, if it's kind of tasty, if it's above 40 tastiness, and he's still pretty happy. But if it's around 20, if it's between 20 and 40, he loses some happiness. Right? It's not that tasty. And if it's actually below 20, he loses a lot of happiness. He hates nasty ass food. Right? But then either way, he eats it and he loses some hunger. Right? Here's his hunger level. It goes down by the food's fillingness value. Right, so here we have these food objects, right? They have a food name, which is a string, as text. It has a tastiness value, and it has a fillingness value. Right? Go down here to where we defined our foods. We have these foods right here: banana, pie, mushroom, and cheeseburger. So what's a food that you guys can think of that's really tasty and really filling? Right? We have this pet food. I don't know what it's called yet. You know, a magic food for now. Dick says dick. You're feeding some dick, huh? Maximum tastiness, maximum fillingness. Right? Coolan says dick. You can feed the pet some dick. There we go. I love feeding my pet some dick. Okay, so let's see here. Pet life. 1, 2, 3, 4. And dick. Let's run our code again here. I actually want to put some more blank lines. It's getting a little bit too crowded in there, huh? Max taste and fullness, but also instantly kills. You won't do it, you scared. We could do that. But the only thing makes the pet super unhappy, though, right? The only way we lose right now is if the pet becomes unhappy. If it reaches 0 happiness, then we die. Because it bites us and kills us instantly. Let's see here. So I want to add a blank line here in our feeding with pets, right? We want to actually have a blank line after all the food types. There we go. Gotta chase that petite mort, huh? Little death. Let's run this. Okay, so I want to feed Katie Alpha some dick. Okay, so we took a shit right away, right? So basically, if our pet's hunger level reaches 0, it takes a dump. So it was already at max hunger, 100. But then the thing is, dick is filling by 100. Went down to 0, took a big shit, but he's really happy, right? Because it makes him max happiness. So that's nice. Now we gotta clean up some poop, though. Because I poop on the ground. Clean it. There you go. Okay. He's kind of hungry again, huh? Well, let's feed Katie Alpha some more dick. There you go. So now he's really, really happy, but he's also taking another dump. Right? Because he goes to max. When he takes a shit, his hunger goes back to max, but when he eats the dick, it goes back down to 0 anyway. So we're like an infinite loop now, right? Infinite loop of feeding Katie Alpha dick and having him take a shit. Right? Because it's an incredible food. Right? Katie Alpha eats the dick. Right? It's a wonder food. That's what I told her. Always very mature here. Okay, so that's kind of like a cheat code, right? Kind of like a cheat code that makes him max happiness, right? But it takes a dump afterward. So that's cool. So what's kind of cool about this, though, is that we used this mold, pet food, to very quickly manufacture a whole bunch of kinds of food. Right? Now, if we didn't have object-oriented programming, making all these foods behave differently would have taken us way longer. Can you guys imagine, right? In our last episode, we didn't know what objects were, what classes were. We couldn't very easily make a bunch of kinds of food. It would have taken us forever. But because we have this awesome pet food class, we can make all kinds of cool pet foods. In fact, we also make more pets too. Right? Got all kinds of cool pets. Why don't we actually add another pet to our game and see how easy that is to add a whole new pet because we have this new system. Right, so I'm going to say here, we'll say, KD Alpha. Well, no, we'll make Dick Sucker. Right. We've got Dick Sucker now. He starts off at max happiness and max hunger. We're going to have Zanzu, who starts off at 20 happiness and 40 hunger. Actually, he might die instantly at that low level happiness. So we're at 40. 40 happiness, 40 hunger. Right, so now instead of having a pet game state, we're going to have a pets list in our game state. It's going to contain two things: Dick Sucker and Zanzu. Okay, awesome. So now we have two pets, which means that when we're taking care of our pets every turn, we can choose which one to take care of. So let's say here, we get a new value here called turn pet. Let's not do that quite yet. Let's say here, we'll say here, pet map equals, we'll make a empty dictionary, right? We're gonna map the pets to their name. So I say here, for pet in the game state pets list, pet map pet.pet name equals pet. So we have a dictionary now that points to each pet, right? Kind of cool. We can actually do that, right up here, actually. So right here, before our while loop, we can make this dictionary from our list of pets. Awesome. I slept in a weird position, huh? Woke up and didn't have that well-slept feeling. I'm sorry, dude. It's always tough, man. Why do we sleep in weird positions, guys? You'd think that we'd be inclined to sleep in a comfortable position, but we always do sleep in weird positions, and we fuck ourselves up. Okay, so I'm going to say here, chosen pet equals input which pet. Actually, let's print off a message here. Let's say, print off which pet do you want to take care of. Right. Then we're going to say here, for pet in game state pets, print pet.pet name. It'll list all of our pets, right? We get the input from the user. Well, how about we say right here, your pets are, right? We're say here, which one do you want to take care of, right? Which pet do you want to take care of? There we go. So now we have a chosen pet, right? Awesome. So now we have this pet activity. We are going to run this player command with the game state, the commands, the chosen pet, and the pet activity. Right? Awesome. So let's go up here to our input pet activity function and make sure it doesn't reference the pet name at all. It doesn't know the pet anymore. Let's go up here to input pet activity. What do you want to play? Let's say, do you want to feed or play? How about that? Just shorten it. Then we can say here, if there's poop on the floor, we can say, do you want to feed or play, or do you want to clean poop? Do you want to feed, play, or clean? Here we go. Awesome. Sweet. I can put this on one line now. All right. Beautiful. Glorious. Can I fit on one line too? Probably not, huh? Not quite. That's fine. Okay, so now we're going to return the pet activity. That's cool. Well, pets can poop. Pets can poop and they have to clean it up. Or they get unhappy. If pets hang out with poop on the ground, they get unhappy very quickly. Because of this line right here. Here's the end turn code, right? This happens at the end of every turn. And if the pet's hunger is above 70, we print off they seem kind of hungry, and then their happiness goes down. If there's poop on the floor when the turn ends, their happiness goes down. And if their happiness is below 0 or equal to 0, then they bite you and it's game over. Right, cool. So we're going to change this now. We're going to say here, you know, for pet in game state pets. Right, so not for every pet, not just for one pet, but for all of our pets. We're going to say here, if they're hungry, print off that they're hungry. Right. That's true of all pets now, every turn. And they're going to get less happy. Exactly, Zanzu. Yeah, we can show that to you real quick. If you start a pet at 0 happiness, the game's over instantly. Well, no, not really, because you actually make them happy. So the game doesn't end until the end of the turn. So if you start off at 0 happiness and you feed a pet a really tasty food, it'll actually save you. Because the turn will end with them at positive happiness. So I was wrong about that. It's not an instant game over. Okay. If there's poop on the floor, then the pet becomes less happy. And, you know, if our pet's happiness is 0 or below, then, say if. And the pet bites you. Right, we'll use an F string. Okay, he bites you. And then poops on the dang carpet. You die from embarrassment. There you go. Sweet. Awesome. So now we have more than one pet. And I think I'll have to change our activity code, right? Here's the, there's that at here. Up here, I think somewhere. Run player command. Yeah, now it takes a pet. Chosen pet. I'll call this pet. Keep it short. So now this run player command, it takes the whole game state, the command map of commands you can possibly run, and then the pet you chose, and then the player command. Right? So when you feed a pet, you choose the pet you want to feed. Right. Awesome. That's true of all these things now, right? So we have this run player command. It can run a feed pet. It has to know the pet now. Play with pet. Has to know the pet now. Put pet to bed. Has to know the pet now. Doesn't really matter, though. It's going to still end the game. Well, no. Let's change this code, right? So now we're going to say here, if you want to put a pet to bed, it removes the pet from the game. Right? So they go to bed. We're going to say here, game state pets dot remove pet. So now this pet's in bed. He's not in the game anymore. Okay, then we're going to say here, if the length of game state pets is 0, then we're done with the game. Okay, so we're going to remove the pet that went to bed, and then we're also going to end the game if there's no more pets awake. So you can't feed multiple pets if you have more than one. You can, but it takes 2 different turns right now. You can't feed both pets at once. You feed one pet one turn and the other pet the next turn. Watch what happens here. Thanks for the sub on YouTube, Flawed Chip. I'm kind of proud of the YouTube channel, to be honest. It does not get a whole lot of viewership. I'm very proud of it. Clean up poop. That just takes the game state. Because you clean up, they both share the same poop game state, so it's all good. We have to take the pet anyway, right? That's fine. And so does this now. They all take pet now, even though they don't need it. Okay. So now we go up here to our run player command. It's going to run this command callable with the game state and the pet you chose. So if both have 0 happiness at the start, it really is game over. Exactly. Exactly. Because you can feed one pet to raise its happiness, the other one you can't feed in time, and it bites you and you're dead. Okay, so I think it's going to make our game multiple pets now. We can have 2 pets or 3 pets or 4 pets, as many pets as we want now. Right? Isn't it crazy how when you learn how to use objects and classes, you can make your game way more complex very, very fast because you can manufacture things very quickly. Right, watch this. I'm going to add a whole new pet instantly. I'm going to add in KD Alpha. Not our put, our pet. Our pet, KD Alpha. We already established he starts at 50 happiness and 100 hunger. There you go. We have 3 pets now. Let's run this game and see if it works. Might have some typos in here, as it oftentimes does. Our pet's not defined. Where's this at? Our pet.dance. Yeah, down here. Get rid of this. Okay, that's fine. Save it. Run it. We still have a lot of typos in here. Let's find out. Okay, it says your pets are Dix and Zon. Oh, I didn't add them to the list. We have to add Katie to the list here. Where's our pets? Our pets. Where is that at? Pets right here. Dix, Zanzu, and KD Alpha. There we go. If we made a pet there, now he's in the list. Run it. Okay, so your pets are Dix, Zanzu, and KD Alpha. Who do you want to take care of? Who's the least happy at the start? I think that's Zanzu, right? Zanzu has 40 happiness, so I want to take care of Zanzu. Do you want to feed or play? I want to feed Zanzu. Oops. Key error pet. Game state pet. Oh, yeah, where is that at? On line 91 in feed pet. Let's see here. Right here. We don't know which pet we chose. It's right here, actually. The pet we chose is right there. I actually want to say here, I want to feed pet.pet name, because I know the chosen pet right there. Okay, here's a pet.pet name, takes a massive dump. Okay. Also, we're going to feed, where's the, let's see, pet food, okay, blah, blah, blah. You can feed the pet these things. Chosen food is that. Then we're going to say here, pet.eat. We can feed our pet individually now. Zanzu breaks the game, as always. Then we're going to have the pet's hunger go up to 100 again if they poop. Just like in real life. There we go. Okay. Also, we have a pet here. We have no more game state pet, because now we have multiple pets, right? We actually give the pet we want to feed as an argument right here. Pet you want to feed is right here. Okay. And only has to know the game state to know if there's poop on the floor or not. So how do you know how much happiness or hunger the pets have if you don't have the code to read? Because it tells you, right? It doesn't tell you exactly. It's part of the fun of the game is trying to figure it out. But there's ways to find out, right? So basically, if the pet's hungry, it'll print off a message here at the end of every turn. Let's go to our end of turn code. So it says here, at the end of every turn, for every pet we have, right? For every pet we have, if that pet's hunger is greater than 70, it prints off, they seem kind of hungry, and they get less happy, because they're hungry still. And also, if you feed a pet, so you do feed a pet, it estimates how happy they are. Let's see it right here. The pet can eat, right? If you feed the pet and it eats, it says here, after it eats, they'll seem ecstatic if they're really happy. They seem in high spirits if they're kind of happy. They seem kind of down if they're not that happy. And if they're below 25 happiness, they seem mad depressed. That means you're getting close to game over. So be careful. Also, if you try and play with a pet, and it's not happy enough, it'll say it's not in the mood to play. That's another way to know that it's not that happy. Right, so both those things mean you gotta be careful. They might be close to game over. But it doesn't tell you exactly. So if they're hungry, it warns you at the end of a turn. And if they are happy after eating, they'll warn you. And also, you try and play with them, they're not happy that you can't play with them. Okay, so let's run this code again. Oh no, let's have to go down to our play with code. Because now we have this. Oh, it still uses self, that pet name, that's fine. Well, let's go to our this play with pet code right here. Right? It doesn't use game state anymore. It has to use the pet we supplied. There is no game state pet anymore. We have this pet that we supplied as our chosen pet, essentially. Same with put pet to bed, right? We don't have a game state pet. We have the pet that we chose. Okay. And right here as well. If we want to cheat, we have to cheat using this pet that we chose. Should be an F string as well. We learned about S strings today. Cleaning up code. Feels so good, man. was an F string anyway, so I gotta break the line here. Let's see here, dagger's the dude. Control A and backspace is a pretty good way to clean up. Control A and backspace? I don't know what that does. I'm afraid to press it. Okay. Sweet. Oh, Control A, like, select all. I gotcha, I gotcha. Okay, so, now let's run this code and see if it works. I want to take care of Zanzu, of course. Who wouldn't? I want to feed Zanzu. Oh, I can't do that here. So we have a string here. Why do we have a pet as a string? That doesn't make any sense. Oh, I know why. Because I go down here to our chosen pet code. It says here, your chosen pet is your input. Right? That's not what I want to say. Chosen pet name is the input, right? That's the name of your pet. To get the actual pet we want, we have to get out of the dictionary we made. We have this pet map here. So chosen pet equals the pet map at that key, chosen pet name. So up here in this for loop, we made a dictionary which pairs strings, in this case, to pets, and the string is that pet's name. So we had an empty dictionary, right? It's empty right there. For pet, in our pets list, it says the pet map maps their name to the pet. Right? So for every pet you have in there, add a new entry to the dictionary. The pet's name goes to the pet. Right? So we have the list of pets right here. Prints off your pets are. Then it says here, chosen pet name is the input that they type in. Right? I typed in the word Zanzu, get this string back as a pet name. Then the chosen pet is the pet map at that string I typed in. Right, now watch this though. We have another problem, right? If I save the game and run it, say I want Zanzu. Okay. Well, now I got Zanzu. That works. But what if I were to run this code and say that I want Vencabot? Boom, crashes. Right, it just crashes. Because it's a key error. Right, it's a key error. I wanted the key Vencabot from this dictionary, the pet map. But there is no key for Vencabot. It doesn't exist. We get a key error and the game crashes. Let's try this. Let's say here, chosen pet equals that. I'm going to say here, try to do that. Right? Try to pick that pet out of the list, out of the dictionary. But if there's a key error, don't crash. Accept the key error if it crashes. And then just print off, you don't have a pet by that name. And if they do that, then continue. Restart the loop. Go back to the top and ask them again what they want to take care of. Let's try it. I'll print off a blank line after that, too. Okay, so let's try this. Save it and run it. So now we're accepting the key error, right? I'm going to take care of Vencabot now. So you don't have a pet by that name. Right? So it didn't crash the program because we put in this try block. Right? It's not this try block. Now try to do this code. If it fails, then accept the key error and run this code instead. Don't crash. Run this code instead. Right? You don't have a pet by that name. Okay, so let's take care of Zanzu now. And I want to feed Zanzu some delicious pie. Oh no! What happened? Something got fucked up here. That's kind of bug. So... Oh, I put this in the wrong... This Fate for Embarrassment thing must be in the wrong area. Let's see, let's go through this Fate for Embarrassment code. Everything happened, yeah. It's the end of the turn, right here. This should be indented. There you go. And so this should be indented as well. So the problem there was that these lines, you faint from embarrassment, and then the game state, game over, that actually was not inside this if block. We talked before about code blocks and indenting, right? So if the pet's happiness was 0 or below, it prints off, pet name bites you, Zanzu bites you, and then poops in the dang carpet. But the problem was these lines were not inside that if block. So these lines always run. They always run. It says you faint, and then you get a game over. Let's put the game over inside that condition, right? You should only get a game over if this is true, right? If the pet's happiness is, below 0, then it's game over. Don't just game over all the time. So if I did this, that's always game over. It's not inside this if block. Put the pie in the wrong area, right? So now it's outside the if block, it always runs. Let's put it inside the if block now. There you go. Now it's only going to run if that's true. Awesome. Run it. Take care of Zanzu. I want to feed him some pie. There we go. So now it says here, Zanzu's a massive dump. Let's see, why is that the case? Is pie that tasty? Oh, because he wasn't at max hunger. Right, so actually he was only at 40 hunger. right? And the pie gave him 40 fillingness. So he hit 0 and took a shit. So now we have a problem, right, guys? Now we have poop on the ground. That means at the end of every turn, our pets are going to be unhappy with us. Right? Because they don't like having poop on the ground. Let's clean up now. Let's say here, I want to take care of, Zanzu. Doesn't really matter who we take care of. I want to clean. Oops, let's see here. So I have this game state pet. It's not a thing anymore. And the cleaning code. Let's go find that. Okay. So we have cleaning around here somewhere. Clean up poop, it says here. Let's say you clean up the poop. There you go. Awesome. Save it, run it, try it again. I'd faint too. Put pie in the wrong area. I want to play with Zanzu. I want to feed him some pie. Okay, so now he took a big shit because he was already at 40 hunger. Now he's at 100 hunger again, that's fine. So I can clean up the poop. Let's take care of Zanzu. And clean up the poop. There we go. It says here, you clean up the poop. Dick seems kind of hungry. Zanzu's kind of hungry. And Katie seems kind of hungry, right? Let's get rid of that blank line in between. Lots of blank lines happening here. They're kind of making it hard to keep up with stuff. Let's go to the ending of the turn code. It says here, they seem kind of hungry. Print a blank line. Get rid of it. There we go. Instead, let's put a blank line at the end of every turn. Right down here. There we go. Save it and run it. Try it again. Take care of Zanzu. I want to feed him some pie. Okay, he took a big poop, but they all seem kind of hungry now. They're all getting unhappier. Every time they're hungry, they're unhappier. So let's but Zanzu's kind of happy now. He's in high spirits. So let's feed Dix. Let's go to Dix. I'll take care of Dick Sucker. I want to feed him some dick. There. So now he's super ecstatic, as you'd expect, but he took a big shit. Right? But now he's hungry again because he's already full after taking that big poop. And Zan's kind of hungry again. Yeah, because he was at, how is he hungry? He was at 100 hunger. And then he took a shit, right? He took a shit. And then, so he lost, that turn, he lost, I think every turn you lose 10 hunger, right? You see here. Oh, no, he took a shit, so he became hungrier. Right, okay, that makes sense. Yeah, he took a shit, he got hungrier. Katie's kind of hungry, so Katie, Zanzu should be fine. If they're below 70... Oh, look, it's a bug. No, it's fine. I have pet hunger reversed. If they're above 70, it says they seem kind of hungry. It should be that... Because they start off at 100 hunger, then they eat food, it goes into 0. I have it confused in my head. So they eat food, it goes into 0. Then it jumps up. As they eat, they become... Okay, that makes sense then. Okay, I see. I got you. Everything's fine. Yeah, so Zanzu, he pooped, now he's hungry again. So let's feed Zanzu. We have to feed Dick Sucker... Well, let's feed Katie Alpha first. He's really hungry. We got a challenge in our game now, guys. Our game's a little more interesting, right? We have to choose who we take care of every turn, and they're all got demands. Oh, there's poop on the floor, too. Fuck. All right, let's clean up the poop. No! Yo, Katie bit me. No! So why did Katie bite me? He started at 50 happiness. Right? Started at 50 happiness. And then he was hungry. Let's try this again. Let's try it again. Do some math here. I want to take care of Zanzu like last time. I want to feed Zanzu pie. Yeah, so I mean, it's 4 turns, right? It's longer than I think. Feed him some pie. Oh, because cleaning the poop takes time. That's why. Cleaning the poop takes time. So I fed him pie. So now he's kind of hungry, right? So he lost 10 happiness. So now he's at 40. Okay, so I'm going to have to clean up the poop now. I want to take care of Zanzu. I want to clean. Now Katie is at 20 happiness, right? No, now he's at 30 happiness. He was at 50. Then I fed Zanzu, he lost 10. He's at 40. Now I cleaned up, now he's at 30. So I'm going to feed Dix. So I'm going to feed Dix. I want to feed Dick Sucker some dick. Oh, he bit me already. What? So why is he losing happiness so fast? He starts off at 50 happiness, right? If they're hungry, they lose 10. If there's poop on the floor... Oh, because that turned out the poop being on the floor. Even though he pooped in that same turn. Oh, okay. So even though he pooped in the same turn, they already had that poop on the ground. Okay, I see. That's why he's biting me. But Dix is already dead. No, he's not, dude. Dix lives in my heart forever. So here's what I'm going to do. Here's my plan. Watch this. Here's my strategy. Run module. I want to take care of KD Alpha first. I'm going to do what Dick Sucker said and put him down. I want to quit KD Alpha. He goes to bed now. Alright, so now I have only 2 pets. Dix and Zanzu. How can I quit KD Alpha? I can't quit you, dude. Alright, so now we can feed Zanzu. Feed him. Give him some pie. Okay, now I took a shit. I'm going to take care of Zanzu and clean the poop. Okay, now I'm going to take care of Dick Sucker. Feed him some dick. Okay, now clean the poop now. I want to take care of Dick Zucker. And I want to clean the poop. Okay, so I got 2 guys that are kind of hungry. That's fine. Let's feed them some pie. I want to feed Dick Sucker first. Thank you for the follow, Nova Mix. We are just sitting here goofing off. We made a cool little game. It's more fun now. It's a lot more interesting now that we have some challenge to it. We're actually going to end the stream very shortly here and play some something. I haven't decided what we're going to play yet. I want to feed Dix some pie. Oh no! Zanzu bit me? What? How? Oh, because Zanzu starts off being... Well, I gave him pie though, man. Where's my math going wrong here? This game's so hard now. So he was at 40 happiness, and then I fed him. No, he actually lost. So I fed him and gained... He gained... Where's the pie at? Yes! Looking for the bits, Dagger. Dude, I can't win my own game, Dagger. I'm a scrub. So the pie gives him 100 happiness, right? No, it's tasty. It gives him a 30 happiness, I think, right? That's 100 tastiness. So up here, if you feed the pet, he gets 30 happiness if it's really tasty. Okay. So we gained 30 happiness on that turn. But he took a shit, so we lost 10. So he was at 70 at that point. Okay. Also, he was hungry. He lost another 10. So he was at 60 at that point. Then I fed Dix, went down by another 10. That cleared up Dix, went down by another 10. Yeah. This game's hard, man. Thank you, Zanzu. Let's try it again. I keep track of the math. Why am I losing so quickly? So, oh, I had to take care of KD first, right? He lost happiness then, too. Let's go to KD Alpha. And I want to put KD to bed. So now KD's in bed. Okay, so Zanzu lost 10 happiness. That's from hunger. Oh no, he's actually not even that hungry. So he's fine right now. Dix is kind of hungry. That's good. So let's go to Dix then. Take care of Dick Sucker. I want to feed Dix. I want to feed him some dick. There you go. So now he took a massive dump. He's kind of hungry. He's losing happiness. That's fine. He's really ecstatic anyway. At least had Dick, his favorite. So now he's kind of hungry. It's whatever. He's going to be losing 10 happiness per turn. And took a shit as well. So he lost. So Zanzu just lost some happiness too. Because Zanzu was there when there's poop on the ground. So now he's unhappy. So he was at 40. Now he's at 30. So I'm going to clean up the poop. Let's see. I want to take care of Dick Sucker. I want to clean. So now the poop is clean. It was clean before the end of the turn too. So Zanzu's still at 30 happiness. How did I die last time? What did I do that got me killed? Well, I fed Dix again because he's hungry again. Okay. But isn't Zanzu still at 30? Why is he so unhappy? Why, Zanzu? Why? What got me killed anyway? His hunger got me killed. Did I feed Zanzu first last time or something? I don't understand. Why is Zanzu getting hungrier? Do they always get hungry at the end of every turn? Oh, maybe they always get hungrier, huh? Oh, he starts at very low hunger. Well, no, he doesn't get hungry at the end of every turn, right? They used to. So why was he even hungry right then? I'm trying to figure out. I'm gonna look at the log here. Feels bad, man. It's okay, Zanzu. Life's hard sometimes. It's confusing to be a human being. Trust me. So why was Zanzu kind of hungry? He was hungry for a minute. Did I feed Zanzu first last time? Oh! So I fed Zanzu pie last time, and he got hungry. But why was his happiness go down so fast? That's what happened. Let's review. Let's go back to the top of our code when we ran that last code. Right up here. Okay, so here's where we died last time. Let's see what happened here. Let's scroll through line by line. How did we die? I figured it out, right? First turn, we put Katie to bed. Okay? Doesn't affect Zanzu at all. He's not any more hungry or any less happy. I fed Zanzu a pie. He's in high spirits now. So he was at 40 happiness, right? When the game starts. Where's Zanzu at? He starts the game at 40 happiness. He ate a pie. Pies have how much tastiness? Pies have 100 tastiness. So he gained 30 happiness. So now he's at 70 happiness. But he took a shit. So it went down from 70 to 60. And now he's hungry. Right? So right here he's hungry, and he was at 60 happiness. But there's shit on the ground. So actually went down by 20. So actually went from being... he was starting the game at 40, went up by 30, and lost 20. So now he's at 50 happiness. Okay. I cleaned his poop. But he's hungry, so now he lost 10 happiness. So now he's down to 40 happiness. Thanks for the follow, R2OS. Be R2OS. Whatever it is, welcome aboard, homeboy. If you have any questions, let me know. We're actually going to end the stream here very shortly and play some something else. We're doing some tutorials here for now, though. Okay. So here's at 40 happiness there. I fed Dix. Now Zanzu's at 30 happiness. Oh, he's actually at 20 because there's a poop on the ground. Oh. And I cleaned the poop. Now Zanzu's at 10 happiness. And I fed Dix. There's 0. Zanzu bites me. You son of a gun, Zanzu. There's going to be Minecraft later, KG. Starting at around midnight. I have a game to play in the meantime. But I haven't decided what it's going to be yet, guys. Well, guys, our game's very hard now. So I can't help it, dude. He's very unhappy. He kind of lashes out. I'm the same way in real life. When I'm unhappy. So... what we accomplished today, guys, we made our game way more complex and way more fun, very simply by adding objects and classes. Right? I really want to point out before we end the stream here that by putting all of our pets' tools into this mold, this class, and all of our food into this class, we can very easily make new pets and make new food. So we have the 3 pets here, no big deal. Right? They can all eat, they can all play, they all have their own happiness and hunger and favorite foods and whatever, all these different attributes about them. They have all these cool things about them now, and we made them all very quickly. And we can actually make our game. We can actually add, even more pets if we wanted to. Right? We can actually add, TF Dagger is a pet. Right? TF Dagger. He starts the game with, 50 happiness, and he's already a little bit. He's pretty well fed. He starts the game at 30 hunger. We actually add, Vencabot to the game. Not our pet. Vencabot. He's always really, really hungry. He's give him 60 happiness. Life's pretty decent right now. 100 hunger. Let's fix this code right here. So we have as many pets as we want now. Make them a lot harder by having more pets. But it's very easy now to add new pets and stuff because we've been using lists. We've been using dictionary. We've been using objects. And next time, guys, we're going to be trying to clean our code a little bit more, make it a little bit more tidy, and add new features again using these cool things we've learned. But guys, we're done in terms of complexity. In terms of adding new tools to our programmer's toolkit, we are now very strong programmers. Of course, it's going to take some of us a little bit longer to get a grasp on classes and stuff. That's why next time we're going to be doing some review on how classes work, how lists work, how dictionaries work. That's the most complex stuff we're going to cover here on Intro to Python. But next time, no new stuff. It's going to be all review and cleaning things up and sort of making us more confident in our tools. But it's pretty cool, right? We actually have a pretty interesting game right now. We're probably going to add some new features, some new things you can do with your pet. I want the pets to be able to play with each other. That's why I made more than one. That could be fun. If you put a pet to sleep, make it wake up in 3 turns and make it hungrier. It's a good idea, Zanzu. It's good for next time. Right? The pets are just kind of like, right now when you put them to sleep, the game's over for them. Right? They kind of go to bed and they'll, they don't wake up, until the next day or whatever, presumably. But we can actually add that so they wake up after a while there. So what Zanzu's proposing, making a game mechanic, right? Put them to sleep temporarily. Yeah, exactly. Put them to sleep temporarily, and then you have that much time to not worry about them. But then they come back, hungrier. It's kind of a cool idea. Or maybe even not hungrier, but just that turn you took to put them to bed makes other guys hungrier, right? So it's kind of like a balancing act. That'll be for next time. Guys, as usual, if you guys enjoy hanging out, want to keep the channel on, then check my Patreon page, patreon.com/Vencabot. Even $1, man, on Patreon is a huge help. Helps me buy gas and groceries. I stream for 40 hours a week. It's a lot of time, it's a lot of effort. When the stream ends, I'm going to stream all night long. I'm working on a new project for the stream's like software side. When the stream ends lately, it's a lot of work. It's very exhausting. But I'm hoping that one day I can kind of take this streaming thing and make it something, that I can live off of more or less. If you're like me, maybe you enjoy the channel, but you really can't help out financially. Maybe you're a part-time worker or you're a student or you're working full-time, but you have a house to pay off and a family to feed and bills to pay. I understand that, guys. I'm the same way. I'm not exactly rolling in dough. Help it free. Get in the chat. Come say hi. Follow on Twitch. Tell your friends we're here. Check out YouTube, guys. On YouTube, I have archives of all of our past episodes, including Intro to Python. Some of the gameplay content on YouTube is not available yet, but the Python stuff's always all available that same week. So we've got seasons 1 through 3 in their entirety on YouTube, and most of season 4 now is on YouTube. It's kind of a cool way to learn Python, I think. I put a lot of my own experience into it. I'm trying to make it easy to understand more or less. I know we're kind of advanced right now. If you're just joining us, it might seem like a lot, but go back and watch the earlier episodes. It's a lot more basic. I'm going to go offline here, guys, and come back in like 30 seconds. See you guys very shortly with something. Until then, peace out. Good stuff, KG. Some other ideas. Diddy Kong Racing, Mario Kart 64 Duo, Donkey Kong Country SNES, a Rystar. Mario Kart 64 would be fun as fuck. I'd be playing it single player though, because I don't want to get net play set up. Yeah. It's kind of a pain sometimes for guys that don't know how to do it. Big Nazi's back, he said. But is he so back that he can tangle with Kashik? That's my question. He's here physically. Diddy Kong Racing would be fun as well. Is he in the present right now to deal with this bullshit? Let's go. I want it to be close. Good vibes, a legend. Any true legend respects MapleStory. That's what I'm saying. Is he back enough? He said he's back. We beat it, Nick. We beat Hitman.
Is he actually back?
I thought we wouldn't. We had like an hour and a half to play it, and we somehow managed to clear 2 stages in that time. That was going to take way longer. I could play Hitman and try and get high scores, which is awesome in that game. It's a great game to play for high scores. A lot of fun. But I try to move things along on the stream when I can, as you know. And we beat the game. Credits went rolling. Not sure I want to spend too much more time with that game on the stream. Thanks for the follow, a Famware. One more time, guys. We do a variety of content here. We do like gameplay here, creative streams, tutorials, etc. Every Friday here, 6 to 9 p.m. Eastern Time. It's Intro to Python. Next week, we're going to be finishing our season of this series by kind of putting the final touches on this code here, making it more clean, making it more object-oriented, talking more about, classes and objects and attributes and methods, talking more about mutability, about lists and dictionaries. I know I kind of went over it very fast. I tend to talk very fast and go over things very fast. We're going to have one final episode where we kind of review things and try and nail certain concepts in more, completely. And then we're going to have our completed game for Season 4. Every season is 6 episodes here, guys. And they start off with the very basics. What is a program? What is Python? How do I install Python? How do I write code? Right, that's episode 1. And then every episode we kind of add new features, add new ideas, become stronger programmers. And I'm kind of proud of that we kind of, escalate from being a very, very simple, very basic program by the end to being a little more complex, a little more fun, a little more interesting. And all seasons are on YouTube, guys. That means, season 1 was Pokemon. Season 2 was like an adventure game like Zork. Season 3 was like an RPG. You could spend gold and buy potions and stuff. And season 4 has been this virtual
My
pet.
friend Bones' heart, right? They're very
And
similar.
again,
Kenny,
episodes 1 of
Bones
each
told me
season is very
playing
basic. Episode
Newbies
6 is the most advanced we get.
because
Typically, we
he's
talk
looking at
about
the game as a
classes
real
at that
type of
point and objects, methods,
Oh my
mutability.
God!
And that's kind of where we stop here for Intro to Python. And there's a lot more to learn about Python,
It's
but by
third
that point, you're
strike.
pretty much ready to
No!
go. Pretty much ready to go and program your own stuff and
That's
kind
1-1.
of explore the rest yourself. I think next time we might even
That's
talk
a
about
go.
libraries too, episode 6 for this season. We kind of missed that this time around.